Now that you have a solid Flutter and Dart foundation, it's time to dive deeper. And that's exactly what we're going to do in this course section here. In this course section here, we're going to build another app, a quiz app, which allows you to start a quiz, then navigate various Flutter-related questions, where the possible answers are actually displayed in random order. And once you went through all questions, you get a summary screen where you can see which questions were answered correctly and which ones were answered incorrectly. And you can, of course, also restart the quiz if you want to. And as you can see, this app is of course a bit more advanced than what we built in the first course section, which makes sense since we're diving deeper into Flutter. And as we'll build this app and go through this section here, you will learn about additional very common Flutter widgets that you should be aware of and how to use these widgets. You will also learn about some new features of existing widgets, which we already did use in the previous section. You will learn how to render conditional and list content and what exactly that is, what I mean by that. But this will also be super important since you will need these concepts in almost any Flutter app you're going to build. And overall, since we're building this slightly more complex app here, you get an overview and an understanding of how such more complex user interfaces could be built, so that by the end of this section, you will have a very solid Flutter toolbox, which you can use to build Flutter apps, and which we then, after this section, of course, also will use to dive even deeper into Flutter. But now, for a start, it's time to dive into this quiz app and more crucial Flutter concepts. Now, for this course section here, I created a brand new Flutter project with the help of the Flutter create command. For example, you could name it Advanced Basics or anything like that. And with that new project created, in there, you should go to your main Dart file in the lib folder and clear all the content that's inside of it, so that you have an empty file again, because again, we're going to start from scratch here, so that we can really also practice what we learned in the previous section, because it is crucial that you got those basics down. And attached you also find a zipped assets folder, which you should unzip and add to your project, which contains an images folder, which contains one image, which we'll use as part of this section here. Not immediately right now, but a little bit later in this section. And with that, you get this empty main.dart file, and we're actually going to start with a challenge for you here. In order to practice what you learned, I challenge you to build this starting screen of the app on your own as an exercise. And in the next lecture, we will build it together, so you can use that next lecture to compare your solution to mine, but definitely try it on your own first. Write all the code that's needed to bring something onto the screen, to tell Flutter that it should create some user interface. Use the knowledge you gained in the previous course section and try creating this user interface. Now, one brief note or hint regarding this user interface here. This button here at the bottom is not a text button as we used it in the previous section, but some other kind of button. And you could, for example, use the Flutter widget catalog, and there maybe look into the material components, just as a hint, to get an overview of which buttons are supported in Flutter apps and which button could be used here to create a button that looks like the button you see here on this screen. So as mentioned, my recommendation is that you try this on your own to practice what you learned. In the next lecture, we'll build this starting screen from scratch together. So, did you succeed? Were you able to build this starting screen? In this video, I will show you one possible solution, and I will show you how I would build this starting screen. It all starts in this empty main.dart file, of course, and there you learned that you must add a main function, because this is kind of a special function which is automatically detected and executed by Dart when your application starts on the target device. This main function in the main.dart file is automatically detected and executed. And in this main function, you must call a special function provided by Flutter the run app function, which then will take a widget, which then is the root widget that will be drawn onto the screen and which will then contain all the other widgets as children and as descendants to build the overall app user interface, as you learned it in the previous course section. There you also learned that run app is not available in this file out of the box. Instead, you have to import it from the Flutter framework. And you do this by adding the import keyword and then the path to the file or to the package file that you want to import. And here we indeed want to import from the Flutter package. Hence we type package:/Flutter. And then here it's the material.dart file, which is the main import file when building Flutter apps. You will import most of the Flutter features from this file. So that's why we have to add it here. And with that, we unlock this run app function. Now to this function, you must pass a widget. And typically here, you start with the material app widget, which is one of the most important widgets provided by Flutter, since this will basically wrap your overall user interface and do a lot of behind the scenes setup work. So that's typically the widget with which you start. And later in this course, you will also learn about the various named arguments that you can pass to this widget constructor function, because there are a lot of things you can configure about the overall app with help of this app widget. But for the moment, we just need to set the home argument, the argument named home, this named argument, and we must set this to a widget that should be displayed inside of our app, because the material app widget itself doesn't really display anything. Instead, it just provides a shell with all that behind the scenes configuration work, as I mentioned, for the actual user interface we want to display. Well, and here inside of material app, I'd like to set the scaffold widget as my home widget. And that's another widget you saw in the previous course section already, because where material app sets up the general app shell, so to say, scaffold can be used to set up the screen that will be displayed to the user. For example, you can use scaffold to set a background color to the screen if you want to. Something we haven't done yet, but which we will do later. So that's why I'm using scaffold inside of material app to configure some settings for the actual screen that's displayed in my app. And here for scaffold at the moment, I just want to set the body argument. So an argument named body accepted by scaffold, and body, just like home, also wants a widget. So here we also must pass a widget as a value. And the widget I want to pass here will be my start screen widget. And for that, I'll build a custom widget. Now we could include this scaffold widget into that start screen custom widget as well, as I just mentioned that scaffold does some screen specific setup work. So including it into the screen widget might make a lot of sense. But since I plan on sharing the same background color and settings for all my screens in this app here, I will actually use this here as a wrapper around my different screens later. And therefore I'll put my screen specific widget combination into a separate custom widget that will then be passed as a value for this body argument to scaffold thereafter. Hence, in this project, in the lib folder, I'll add a new file, because you learned in the previous section that it's considered a good practice to put custom widgets into their own files. So that's what I'll do here. And I'll add a start_screen.dart file here. Following that naming pattern, that naming convention you learned about in the previous section, where your file names should be all lowercase, and if they happen to consist of multiple words, these words should be separated by underscores for better readability. So here it's the startScreen.dart file which I add, and in there we create a custom widget which, as you learned, is done with help of the class keyword, because we must create a class, a blueprint for an object. Because remember, Dart is an object-oriented language all values are objects, and for more complex values like widgets or configuration objects or anything like that, you use classes as blueprints to basically tell Dart how these objects should then be created and which kind of data and logic, so functions, should belong to the object that will be created. Since these objects are all about organizing data and separating logic, so that logic that works with certain data is co-located with that data in the same object, and logic that does something else is in a different object, for example. Therefore, here we build our custom start screen widget by using the class keyword, and then start screen sounds like a fitting widget name, though the name is up to you, but it of course should describe what this widget is all about, and it should follow this naming scheme here, where you start with an uppercase character, and if your widget name consists of multiple words, as this one here does, then every word inside of the word also starts with an uppercase character. Now, you also learned in the previous section that your widget classes must extend one of two main widget classes provided by Flutter. And that's either stateless widget or stateful widget. And here, for this starting screen, since we at the moment don't need any changing data, we can simply use stateless widget. If you chose stateful widget because we'll have a button in this widget, that's not a wrong thought, but we'll handle this button slightly differently later, which is why you can use stateless widget. Now, to unlock this stateless widget class from which we extend here, we again have to import from Flutter material to be precise. And then inside of this custom widget class, we must add a build method. That's what you have to add to your stateless widgets. The build method here must return a widget, so a value of type widget, and it should accept a context argument, which we didn't use thus far, but which we will see in action, or which we will use later in the course. We should accept it though, to make sure that we're implementing this build method correctly, because stateless widget actually wants us to implement build method, and it wants us to implement this method in a correct way. And we should therefore also add the @override annotation here to make it clear that we're in the end implementing, and as it turns out, also overriding a method expected by stateless widget. Now, in the body of this build function, this build method here, we then have to return a widget, and for the moment, to just have anything on the screen, I'll return some text using the built-in text widget, and in there I'll just say start screen like this. Now, we can add const in front of this to unlock this extra performance optimization, where Dart is able to reuse certain objects, certain data structures in memory. And Visual Studio Code simply tells us that we can use const here, so that's quite convenient. We basically can't miss this opportunity. And we also have to add a constructor function here by repeating the class name. And in this constructor function, we should accept a named argument. Hence, we need curly braces here, called key. And this argument needs to be forwarded to the parent widget, to stateless widget. And as you learned in the previous section, this can easily be done by using super.key here, which is simply some Dart shortcut for saying that you want to accept an argument named key and forward it to the super class, so the parent class from which you're inheriting. And there it should also be passed to an argument named key. And stateless widget indeed will accept a named key argument. You can then also add const here in front of start screen, as you're also told by Visual Studio Code, so that you unlock this custom widget class for being used in conjunction with const, so that it could then also be reused after being created and stored in memory. And with that, I got a basic start screen widget class here. Of course, not the final version, not the solution of this task, but a start. And back in main.dart file, we can now use this as a value for body in the scaffold widget. We can use the start screen widget here. And in order to unlock this widget here, we have to import it, because in Dart, whenever you're using something, for example, a class defined in some other file, you explicitly have to import that other file. Dart will not automatically connect your files. It does not do that. So therefore here we add another import. And if you want to import from your own files, you can still do this with help of package, but now you use your project name, in my case fbasics, and then there you point at the file from which you want to import, in this case startscreen.dart. Now we can also add const here to unlock these potential performance improvements. And as you learned in the previous section, you should add a comma after every closing parentheses here, so that if you then press the format document shortcut, this code gets formatted and is a bit easier to read and understand. And with all of that, we have a very basic widget tree using a custom widget. And that's a great start, and we can now make sure that we have an emulator up and running, and with that, run this app here on that emulator, and see whether we see our output here, the start screen output, on the screen. And here, that's looking good. I have start screen here. It's not centered. You can barely see it, but it's there. I have this white background from the scaffold widget. I have no error, so this is looking good. And we can therefore now continue with this solution to this first exercise. So I got started with my solution here, and to continue, I now want to change the background color, because in the expected solution that I showed you before, I wanted to have a nice gradient background. And that is of course also something that we already implemented in the previous course section. So in order to add this gradient, we can wrap the start screen widget with the container widget, because that container widget will then allow us to set a decoration on it. And I will indeed wrap the start screen widget instead of putting the container into the start screen widget, since, as mentioned earlier, I want to use the same screen setup and screen background for all the screens I'm about to add. And therefore I'll not put it into a specific screen, but instead wrap it around this screen. Now to wrap a widget around my custom start screen widget, I can right click on it and choose this refactor option, and then wrap this with a container. So choose this option here. With that, we add this container widget, and we are now forced to remove const here because container does not support it, at least not at the point of time I'm recording this. But I can add it in front of start screen still, because that's inside of the container, and my custom start screen widget does support const because of this const constructor. And on container, we now can add more options than just child. We can and should, for example, add the decoration option, which allows us to add a box decoration object by using the box decoration constructor function, which then in turn can be used to set a gradient. And that's exactly what I want to do here. And here I'll again go for a linear gradient as I did it in the previous section, and format this code a little bit. And to this linear gradient constructor function, which will create such a linear gradient configuration object, which then is used by box decoration and ultimately by container, we can pass a colors argument. So a named argument with the name colors. And colors wants a list of colors, and you learned about this list type in the previous course section as well. It's a generic type, which simply means that we got one type, list in this case, which works together with another type, and it is quite flexible regarding which exact type that is. Here it's the type color, but you could in other places of your app also have lists of strings or numbers or any other values, but here it's a list of colors. And such a list is created by using square brackets, and then between those square brackets you put your list values. And that should at least be 2 colors to create a nice gradient. And to pick those colors, I'll start with a nice deep purple maybe, like in the last course section. And if you then hover over that, you should get a nice color picker here in Visual Studio Code. And I will now choose a, well, again, relatively dark purple color, but a bit more purplish than in the last section. And then copy that color and add it again as a second value in that list, but now hover over that second color here and choose a different purple tone, like that. Now we can add const here, since all these configuration objects do have const constructors and therefore can use this optimization technique here by adding const in front of them when created as objects, so when the constructor functions are called. And with that, if we save this and we force an update on the emulator, I do indeed have some purple here, but that's of course not what I intended. I'd like to have this on the entire screen instead. Well, for that we first of all have to pick some content inside of the container that really occupies the entire screen. And this text widget at the moment does not do that. Instead, that only occupies as much space as is needed to display this text. Now that can be changed by wrapping it with another widget, to be precise, the center widget. This center widget, as its name implies, centers its child widget, its content, so in this case this text widget, inside of it, both horizontally and vertically. And in order to do that, the center widget will try to get as much space as it can. And since this center widget is in the end the first widget used inside of that container that's inside of scaffold, it will in the end take up the entire available screen, because neither scaffold nor container do by default take up any space themselves. Therefore, center will basically expand to take the entire screen width and height, and hence the surrounding scaffold and container widgets will apply their settings and their decorations to the center widget. That's how this here works, and by using center here, we'll make sure that we get the background color on the entire screen. So here I'll add a comma and move this const keyword here in front of center, since center also supports it. And now with that, this looks much better. Now this indeed does take up the entire screen. Now I'd like to have the gradient flow from the top left to the bottom right corner, as I had it in the previous course section, and for that back in main.dart we can go back to the linear gradient constructor function and not just pass a colors argument, but also a begin argument, which wants an alignment geometry value, which can be created by using alignment, and then you could manually enter some coordinates here, or use one of these predefined values by using the dot notation directly on the alignment class. And here I'll use top left as a begin value, and for add I'll use alignment bottom right, like this. And with that, if I save this, now this gradient indeed flows from the top left to the bottom right corner. So that's looking better. Of course, that's still not all though. Inside of the start screen, I now wanted to have three main elements, if you take another look at the expected solution. I wanted to have an image, then below that some text, and then below that a button. And when you have a scenario like this, where you want to have multiple widgets above each other or next to each other, you might want to use column for widgets above each other or row for widgets next to each other. Now we'll see row in action later in this section. For the moment it's column that we need, since I want to have multiple widgets laid out on the screen vertically. And column wants a children argument, an argument named children, which then in turn wants a list of widgets. So we create a list with square brackets, and in there we then define all the widgets that should make up this column. Now column does not support the const keyword, hence you should remove it here to get rid of this error. And now we can get started adding our widgets here. And I'll start with an image. I did provide that image earlier in this section already. It's this assets zip file which you found attached to lecture 2 in this lecture. In that assets folder you find a subfolder named images, and in that images subfolder you have this quiz logo PNG file. And it's now this image which I want to output here. And to output such an image, it's not enough to just add it to your project. Instead, as you learned in the previous course section, you also have to go to your pubspec.yaml file. And in there, if you scroll down, you should find this assets section, which you should comment in so that it is active. And then there, below assets, after hitting the tab key once to indent this, you should add a dash and then Basically list all your assets, all your images, for example, that should be usable in this Flutter app. And for that, you specify the relative project path to that asset. So in my case, assets/images/ and then the name of the image. And once you did that, this asset can be used in your code. And you can use this image asset and display it with help of the image widget, which is also built into Flutter. The image widget can be constructed like this, and then you would have to provide an image argument which wants an image provider. But if you have an asset, a locally stored image that should be displayed, it's easier to display that by using another constructor function offered by the image widget class, and that would be the asset constructor function. To that, you simply pass a string created with these single quotes that contains the path to the image that should be displayed. So in this case, assets/images/quiz logo.png, and you're good to go. If you now add a comma here for better formatting, and you then save everything, this image should be displayed on the screen. At the moment, it's a little bit too big though. I'd like to shrink it and I'd like to center it vertically. Now to shrink it, you can pass another named argument to this image asset constructor function, and that would be the width argument. And here you can set a width in pixels, for example 300. If you do that, the image will be shrunk. Now to center it, since we are already here in a center widget, you can simply go to your column and there set the main axis size to main axis size.min, so that instead of taking all the available vertical space, which it will do by default, the column widget will only take as minimal vertical space as needed, so only the height of this image in this case. And main axis size refers to the vertical size because for a column, the main axis is the vertical axis. So with that, this image is now in the center. Of course, this image was just one of the widgets that should be added here inside of this column, and it's therefore time to also add the two remaining widgets. Hence, next I want to add some text, since some text should be displayed below the image. And here the text that should be displayed is "Learn Flutter the fun way." Like this, and here you can add const in front of it since this text widget can be optimized. Now if I do that, this text indeed does show up here, but it got a couple of problems. For one, it's way too close to the image. It would be better to have some spacing between image and text. And of course, I also want this text to be a bit bigger and to have a white color or some color that's a bit easier to see in front of this purple background. Now for the spacing, you can, for example, add a sized box as an extra widget between the image and this text widget. Sized box is simply a widget where you as a developer can define the exact size of the widget, so that it does not take all the available space, like center does, or just as much space as the content needs, as text does, but that it instead takes exactly that amount of space that you tell it to take. And here we could, for example, set the height argument, so pass a value for the named height argument of, let's say, 80. You can then also add const in front of this, and with that we got some spacing here, which is good. Now, of course, I also want to change the text color and size, and that can be done by going to the text widget and adding the style argument. This, as you learned in the previous section, should be set to a value of type text style, and such a value can be created with the text style constructor function that is provided by Flutter. So we're using a built-in class here provided by Flutter. And to this text style constructor function, you can, for example, pass a color value and set this to white as a color. Or maybe if you want to get fancy, pick a color that is maybe some very light whitish purple, something like this. We can give this a try as well. I also wanted to increase the font size, and for this we can use the font size argument here and set this maybe to 24. If you do that and save everything, the text is now bigger and easier to read. Now, last but not least, I want to have a button below that text that can be clicked to then later start the quiz. And here in the expected solution, I actually wanted to have a button that has a visible border. So for that, I'll first of all add a comma here and format this to make this easier to read. But then below this text widget, I'll add another sized box widget to add some extra space between the text and the button. And this can be const and can again have a height of, let's say, 30. Let's see if this works. And below this, we can then add the button. And for adding a button that has a visible border, we can go to the widget catalog provided by Flutter. And there, under Material Components, we find a Buttons area. And in that area, we, for example, find this outlined button, which looks like the kind of button I want to use here. So to use it, we can then create it here, outlined button. And to the onPressed argument, I'll simply pass an empty anonymous function right now. You learned that you can create anonymous functions like this in the last section as well. So this is how you can create a function that is only available here in this place, and that's passed as a value to the onPressed argument. But since it contains no code in the function body, this function won't do anything here. Of course, we're going to change this later. But first, I want to go to my child here and set this to a text widget so that we can define the text that should be shown on this button. And here I'll just add a text of start quiz. And this can be turned into a constant object by adding the const keyword. Now with that, we have that button here, but I'm not too happy with the styling. So to change the styling, we can add a style argument here. And this should be set to a button style. And whilst you can construct a button style manually with the button style class provided by Flutter, the easier way of doing that, which you also kind of saw in the last section already, there just with text button instead of outlined button, but the easier way, which works for outlined button as well, is to use the outlined button class and there call the built-in style from method. And style from then makes it a bit easier to apply various style settings to this button. For example, here we can set the foreground color, which will be the text color in the end, and set this, for example, to white. And with that, the button looks like this now, and the text is way easier to read. And that's the final solution for this exercise. That's where we're going to continue in the next lecture to learn more about Flutter, available widgets, available configuration options, and much more. But this is the solution to the exercise, and this also was a quick summary of some core concepts and widgets about which you learned in the previous course section. Therefore, it's now time to continue and learn some new things. So let's continue working on this app. And of course, an important next step will be to make this button work so that we then actually visit a different page on the screen where we get a question which we then can answer. But before we do that, I want to tweak this button a bit more, the styling or the look of this button to be precise. And I also want to tweak this image a little bit. Now for the image, I want to make it slightly transparent. For the button, I want to add an icon inside of it so that it's not just some text here, but instead some text combined with an icon. And we'll start with that button where I want to add an icon. Because that, of course, could be a very common requirement in the apps you want to build, and thankfully it is quite simple and straightforward to do. If you want to turn this outlined button here into an outlined button with an icon, you can use an alternative constructor function that's offered by Flutter on this widget. For this, you can add a dot to access this extra constructor function, and here it's the icon constructor function. And this does what the name implies, it adds an icon to the button. Now, if you use that constructor function, you can still use onPressed and you can still use style, but child is no longer called child, but instead here it's the label argument that should be used to define the widget that then defines the non-icon content of this button. But of course, you also do want to add an icon, and that's done with the icon argument that can now be set when using this icon constructor function. And this icon argument here wants a widget. And therefore, technically, you could of course provide any kind of widget here, for example, also another text widget. But typically, you of course indeed want to, well, create an icon here, and for that, Flutter gives you the icon widget, which, and that's really important, can also be used outside of this icon button. Icon is a regular widget provided by Flutter, and you can use it anywhere else where widgets can be used. For example, here inside of this column widget, if you wanted to add a standalone icon. If it should be a clickable icon though, you want to use something like outlined button icon, and then here you set the icon argument to such an icon widget. Now this icon widget constructor function then needs some icon data. It actually takes a bunch of named parameters that can be set, but it has one positional argument that should be set, and that's the icon data, which is simply a pointer, you could say, at the concrete icon that should be displayed on the screen. And for this, Flutter gives you the utility icons class, which, when used with a dot here, offers you a bunch of predefined icons. And if you cycle through these icons, you should actually also get a preview of these icons, which makes it very easy to pick just the right one for your use case. And here I want to use the arrow right alt icon here. But of course you can use any icon you want, but this icons class here makes it very easy to use all these built-in predefined icons that ship with Flutter. And with that, we just have to add const here, or we should add const here to be precise. And if you now save everything, you should have this button with this icon here now. So that's how icons can be added. As I mentioned, I also want to tweak this image here a little bit though, and I want to make it slightly transparent. Now there are two main ways of doing that, and whilst one approach is better than the other, I still want to show you both here. The first approach, which is typically not recommended, but which you should still know, is that you wrap this image widget with another widget. Now, not a widget which is suggested here, but instead we can use this generic wrap with widget refactoring action here. And then we can enter the widget name here manually. In this case, it's the opacity widget which I want to use. Now, the opacity widget then does not just need a named child argument, but instead it also needs an opacity argument. And indeed, this opacity argument is required. It must be set when using this opacity widget. And opacity now takes a number value between 0.0 and 1.0, where 1.0 is fully opaque, so fully visible, and 0.0 is fully transparent, so fully invisible. So if I set this to 0.5 here, for example, you see that now this image has some transparency. If I set it to 0.1, this is even clearer to see because now it's almost invisible. So that's one way of setting the transparency of a widget, of the widget that is wrapped by transparency, to be precise. Now this can be useful, but behind the scenes this is quite performance intensive. Not a huge problem for this basic app here, but typically you should avoid using opacity if you can avoid it. And that's why I'll copy this and then comment it out and re-add it, but now I'll remove this opacity widget here and go back to just having the image asset here and show you an alternative approach. Because whenever you have a widget where you can set a color, there is a better approach available, a better approach than using opacity. And it turns out that for image, you can set a color argument when using this asset constructor function. And this color can be used to apply some transparency to this image. Now for a start, let's set this to colors.red, so to the standard built-in red color, and let's see what that does. And as you see, it changes the color of the image. And that's also good to know. This color argument on the image widget can be used to add an overlay color on top of the image, which sometimes can be exactly the effect you want. But this gets even more powerful if you now apply a transparent color here. And for that here, since I want to keep my image white, I'll first of all switch to white. And then here we have this transparency slider. And here it's fully opaque if this is at the top. Here at the bottom it would be invisible. And we can now tweak this and maybe go somewhere here so that this first value here is 150. And with this, we now add a white overlay color that has some transparency applied to it. Now this can be set to a const value by adding the const keyword. And if you do that now, you got a white image again, but a slightly transparent image. And of course here you can also play around with that. If you set this to 20, for example, it's almost entirely invisible. If you would set it to 255, which is the maximum value that is allowed here, it would be fully opaque. And here I'll go for 150, which is what I had before, to have a slightly transparent image. And these are some additional styling things that you can do in your app to make it look exactly the way it should look. So for the moment, that's now my finished start screen widget with the image here, with some text, and with this outlined button. The next step now is to make sure that this button actually does something when we press it, that it does lead us to a different screen. So let's now work towards the goal of making this button work, so that when we tap it, we navigate to a different screen that shows us these questions, which we can answer. Now for that, we of course need to tweak this function, which is passed as a value to onPressed, because in the end, that is the function, and therefore this here is the code that will be executed when the button is pressed. But what exactly should we do here? Well, in the end, what we want to do here is we want to replace this start screen widget here with a different widget. So that instead of showing start screen inside of our scaffold and container here, we show that questions screen, or however we want to name it. So for that, of course, we need a new screen, but then we also need a way of replacing this start screen here with that other screen after this button down here was pressed. So after this function here executed. And for that, to implement this solution, we'll need to dive into a couple of new concepts. To be precise, over the next lectures, you will learn how to render content conditionally and how to lift state up. Now, before we start rendering content conditionally and lifting state up, I'll first of all create two new widgets. I'll create a new widget, which in the end will contain my material app here with all its content, because we'll need that custom widget a little bit later for lifting that state up, but I'll get back to that once we're ready for that. I just want to create the widget for this already. And we'll need another new widget for this questions screen to which we want to switch. So for that, in the lib folder, I'll add a new file called quiz.dart, which should contain this material app here. And another new file, which could be called questions screen.dart. And in both files, new widgets should be created. And of course, to practice what you learned, definitely try building these two widgets on your own first. It should both be stateful widgets, because we will later need these widgets to be stateful. And in the previous course section, you learned how to build stateful widgets. Therefore, definitely try this on your own. In the questions screen widget, you can then simply return some text widget or anything like this. And in the quiz widget, you should return this material app with all its content. You don't need to do anything else with these two widgets. You don't need to import them or use them in other files. Just create them. And after a short pause, which I give you to pause the video and try creating these widgets on your own, I will build them together with you so that you can compare your solution to mine. So, did you succeed? Let's now build these two widgets, and I'll start with the quiz widget in the quiz.dart file. For that, we again use the class keyword, and then I'll name it quiz. Not quiz screen or anything like that, just quiz. because that will basically be my main widget that later manages the entire quiz. And as mentioned, this should be a stateful widget, hence you should extend stateful widget, which is a class provided by Flutter, and therefore, of course, you must import package Flutter Material Dart as you learned it. With that, we create this stateful widget, and as you learned in the previous section, when building a stateful widget, you in the end always end up with two classes that must be built. So therefore, besides building this stateful widget class here, we also need a second class, and that will be the quiz state class. The name is generally up to you, but the convention is to use your widget class name and append state, and also add a leading underscore to turn this into a private class, which technically can only be used in this file here, in the quiz.dart file in this case, and not in any other files, because this class, this quiz state class, will be connected to this quiz widget class here soon. So that's why you should name it like this. And this also extends something provided by Flutter, and that something is the state class, which is a generic class though, as you can tell by these angle brackets. And in the end, that simply means that this state class and type is closely connected to another class and type therefore. And to kind of establish this connection, you add these opening and closing angle brackets as you learned it. And between those angle brackets, you have the name of that other type to which this class will be connected in the end. And here that's the quiz widget class. So you add this here, and inside of this quiz state class here, you then must add a build method, which returns a widget, which takes this context argument, and which should also receive this @override annotation. And then in here, you return your widget or a combination of widgets. And as mentioned before, for this quiz widget, that should simply be the material app here. Like this. So I'll cut this here and then go to my quiz widget file and return material app here. Like this. Now in there, I'm using this start screen widget, and therefore I have to bring this import here from the main.dart file into my quiz widget file here, like that. Now with that, we're not done though. That's just the quiz state. That's not everything we have to do. Instead, we now have to go to the quiz widget class here and also add something to that class. And here you should add a create state method, which must return a state value. And state, as mentioned, is a generic type. So here it must also be defined in a generic way. And here you also refer to that quiz widget class, which in the end just says that create state creates an instance of a class that's based on state connected to quiz. So an instance of this quiz state class here in our case. And that's therefore what you should do inside of create state. You should return an instance of this quiz state class by calling the quiz state class constructor. Of course, here we haven't added a constructor function, but as you learned in the previous section, you also don't have to add one. Instead, Dart automatically gives you one if you haven't added a custom one. Now here you should then also add override on create state. And for the quiz widget here, we also then should add a constructor function where you should accept and forward that named key argument and turn this into a const constructor. And that is now this quiz stateful widget. That's the widget class. And then below that, we have the quiz state class, which in its build method returns this material app. So that's the first of the two widgets that should be added. The second widget should be added in the questions screen file here. And there, just as before, you add your class questions screen, which extends stateful widget. And of course here you then also import from package, Flutter, and then there material.dart. And we add our create state method here. And to do this a bit quicker, you can also open this suggestions menu by pressing Ctrl space. And with that create state suggestion selected, if you hit tab, this is added for you. And you just need to replace stateful widget here with questions screen and replace this part inside of create state with the actual code where you create a state. And for that, we need to add that second class, of course, which in this case is called _questions screen state, and which extends state connected to questions screen like this. And then, of course, inside of that state class here, you add the build method. And for that, you can also start typing build and then choose this build suggestion, hit tab, and it's added for you. You can get rid of this type annotation in front of context. It's actually not needed here. And then inside of this build method, you just return a widget, for example, the text widget, where you could say questions screen. Like this. And of course, we'll change this later, but it's some good dummy content for now. Inside of create state, you then return an instance of this _questions screen state class like this. So you instantiate this class, you create an object based on this class, so to say. And of course, just as before, you should add this constructor function where you get and forward that key argument. And that's these two classes added. Now with them added, I at least want to use the quiz widget which we added in the main Dart file, because here I want to output my quiz widget or pass this to run app. And I can do that since inside of that quiz widget, I am of course using material app. So in the end, by using my custom widget here and passing it to run app, I still use this material app, just wrapped into my custom widget here. And for this quiz widget to be available here, of course, you also must add an import statement to this main.dart file and import from your own package here, and they are from the quiz.dart file like this. You can then add const here because quiz does have a constant constructor. And if this is now saved and you force the app to reload, you should have the same output as before, but now the app is prepared such that we can start working on this button. Now, as mentioned before, to make sure that we switch to a different screen if we tap this button, we must dive into two important new concepts: rendering content conditionally and lifting state up. And I want to start with rendering content conditionally. In our quiz widget, which is the main widget we use for starting our overall user interface, we are at the moment displaying the start screen in the end, wrapped inside of material app, scaffold, and our container with a gradient, but wrapped in there, we're outputting the start screen. And if you want to replace some content on the screen with some other content, for example, after a button has been pressed, you simply have to replace the widget here in your code because the entire user interface is controlled with code. So what we could do here is that in our quiz state class maybe, we have a variable which could be the active screen, if you want to call it like this. And active screen could be set equal to start screen, like that. And this is something we haven't done up to this point, but you can store widgets in variables. This is absolutely allowed because widgets are just objects and objects are just regular values in Dart. So you're not limited to storing some text or some numbers like 30, but you can store widgets inside of variables. And that's what I'm doing here, storing a widget in a variable. And of course, here we can add const, but it's still a widget. And now we can, of course, add a method here to this quiz state class, which could be called switch screen, where we want to navigate to a different screen. So which returns no value, but in which we use setState, a function provided by Flutter that's available inside of classes that extend state, as you learned. And to setState, you have to pass a function, for example, an anonymous function. And in this function, you then should perform any data changing activities that should be reflected on the user interface. So in there, we could set active screen to our questions screen here. And for that, of course, questions screen must be imported. So you must add an import statement where you import from your own package and there from the questions screen.dart file. With that, questions screen should be available if I add the missing S. And we would now overwrite the value stored in active screen with this screen widget here when executing switch screen. Now at the moment this causes an error because a value of type questions screen indeed can't be assigned to a variable of type start screen, and we get this error because active screen infers its type from the value that's used for initializing this variable, and this value, whilst being a widget, is of course also of type start screen. Because whenever you create a class in Dart, that class also automatically gives you a type of the same name. So the start screen class, which we defined here, also gives us a start screen type. And that type in the end is based on the widget type, but is a bit more specific than the widget type. It's specific to this class with exactly its details, its extra properties, or whatever it might have. So in order to make sure that active screen is a bit less restrictive and accepts all kinds of widgets, not just start screen, you can replace var here with widget. And that's one of the use cases or scenarios where you indeed would want to replace var with a more specific type. Because here I don't want to use Dart's type inference because it's too restrictive, and instead set active screen to a more general type, which in the end is met by both start screen and by questions screen. And now if we add const here as well, we would have some valid code that would actually change this variable value whenever this function is executed. And how does this help us? Well, this helps us because now we can use the active screen variable down here as a value for child. Because child, and that's important to keep in mind, just wants a widget. And of course, active screen now stores a widget. So we can use active screen as a value here for child because this simply leads to Dart looking into this variable and using that value that's currently stored in this active screen variable as a value for this child argument. So that's how we could conveniently output different widgets here by simply storing different widgets in a variable. And since we call setState, and that's also why it's important to call setState, this build method will be executed again. Because that's what setState does in Flutter apps. When you call setState in a state class, so a class connected to a stateful widget, Flutter will re-execute the build method and therefore run all this code here again, and then it will compare the result of executing that code to the result it got the last time it executed the build method. And if there are any differences, it goes ahead and updates the rendered UI accordingly. And indeed here for this widget, for the quiz widget, when the build method is executed for the first time, active screen will be set to start screen, and that will therefore be used as a value down there, and hence the start screen would be displayed. But if then for whatever reason switch screen executed and active screen would be set to question screen with help of setState, the build method would run again, but now active screen is equal to questions screen, and therefore down here questions screen would be output. And Dart would detect that there are differences between these two widget trees, the old one and the new one, and it would update the UI accordingly. That's important to understand, which is why I'm emphasizing it. And this approach we're using here, where we're setting a variable to different values, is one way of rendering content conditionally. It's not the only way, and you'll see some other ways later as well, but this is one way. But of course, at the moment, we're never executing switch screen. This switch screen function here, the switch screen method, is not connected to this button. And that's of course what must change, and that's exactly what we'll do by lifting the state up. So what's this lifting state up concept all about? Well, at the moment, in our application, we have the problem that we have the start screen, which welcomes the user and provides this start quiz button. But we then also have the questions screen to which we want to navigate when that button is pressed. So the problem that we have here is that the button that should trigger the state change is in one widget, and the widget that should be affected by the state change is another widget. So we have kind of two widgets that need to work with the same state or that depend on the same state. And the solution here is to lift the state up, which is why we already created that quiz widget. If we manage our state in that quiz widget, and we then also have the function for manipulating the state in there, we can conveniently move between these two different widgets by rendering content conditionally. And that's of course what we're already doing here. We do already manage and update some state in this quiz widget in the end, in the state class that is connected to this quiz widget. And we are rendering the content conditionally already. So we basically already lifted the state up, but we haven't connected this switch screen function to the screen that contains the button that should trigger this function or this method here. And that is another important and therefore at the moment missing aspect of this lifting the state up concept. It's not enough to just manage the state in some shared parent widget, which quiz here is. It's the parent widget of both start screen and questions screen, but it's not enough to just manage the state here, but instead you also must make sure that the child widget that should initiate the state change, in this case the start screen widget, gets access to the state changing function defined in this parent widget. So in this case, start screen needs to get access to this switch screen function. And how do we now do that? Well, you might remember that in the previous course section, I did explain that functions in Dart are also just regular values. There we also had a button that should trigger some function, and in that case back then it was a function, a method defined in the same file, but still it was a method that should be triggered when a button was pressed. And to do that, we passed a pointer at that function. So we used the function name in the end as a value to that button, and internally that button would then call that function when the button was pressed. And we can do the same here with our own custom widget. We can pass a pointer at switch screen to start screen. So simply by using the name of that method, switch screen, like this. So you don't add parentheses here, because that would execute this function when this line of code here is executed, and that would be too early. Instead, you just use the name of the function or method here, and that in the end, under the hood, passes a pointer to that function as a value to start screen. And inside of that start screen widget, you can then use that function to call it whenever you want. For example, when some timer expired or when this button down there was pressed. Now at the moment this doesn't work because we're basically passing in too many arguments to start screen, because I'm passing in one argument here, the pointer at the switch screen function, but start screen at the moment doesn't want any positional arguments. It just has this one named argument here. Now that can be changed though. We can add a positional argument to start screen, and we could also add a named argument, but here I'll go for a positional argument. And this argument could be called start quiz. The name is totally up to you. But now we're accepting this positional argument, and we should also define the type of this argument by adding it in front of the argument name. And here the type is function, which is a special type built into Dart. To be precise, it's a void function, and you should now also add parentheses here, which simply means that start quiz should be a function, and function is a type built into Dart. So it should be a function that takes no arguments, because indeed switch screen does not take any arguments. So as a value for start quiz, we want to get a pointer at a function that takes no arguments and that also doesn't return a value. And that's exactly what switch screen does. It is a function that takes no arguments and returns nothing. And with that, we're passing a pointer at this function as a value to start screen. So now we can call this function from inside start screen by simply executing start quiz like a function, because it is a function basically. Start quiz is an argument that contains a function as a value. That's what we set up here. And I'm spending a lot of time on this because this can be a super confusing concept, but in the end, it's all about a standard Dart feature. You are able to use functions as values and therefore to also pass them as values to other functions or to constructor functions, as we're doing it here. But with that alone, we're not done. We're accepting this argument here, but as you also learned in the previous course section, this alone is not enough, because the arguments you accept here in your constructor function can, for example, not be used in your build method. So we can't use it down there where we would want to use it, because that's where our button is to which this function should be connected in the end. What we should therefore do is we should add a new variable, or even better, a final variable here to start screen, because we'll only set this once when the start screen widget is created. And this final variable will be of this type, so we can cut this type. And here we could name this start quiz as well. And now with that name being equal to that name, we can use that shortcut built into Dart where we add this dot in front of start quiz to automatically set the value we get here for this argument as a value for this variable here. So in the end, when this widget class is created, when the object is instantiated, this start quiz variable is set to the value we receive on this start quiz argument. And with that, we now have this variable, this start quiz variable, which can now be used anywhere in this class, including this build method. So now down here, for onPressed on this outlined button, we can use start quiz and execute it like a function in this anonymous function. And by the way, here we're doing the same thing as we did here in the quiz state class. Here in quiz state, we're passing a pointer at switch screen as a value to start screen. In the start screen widget, we're passing this anonymous function, a pointer at this anonymous function, therefore, as a value to onPressed. That's the same pattern in the end. And in this anonymous function body, we're executing our own start quiz function, but this anonymous function body will only be executed when the button is pressed, because the anonymous function is passed as a value to the onPressed argument, and that argument is used internally inside of that button to then execute this function whenever the button is tapped. And therefore this code in this function body also only executes when the button is tapped. Alternatively, we could also replace this anonymous function with a pointer at start quiz. So this start quiz variable, which we added here. Keep in mind that in that variable, we store a function. And therefore, of course, we can use this variable as a value for onPressed, because onPressed wants a function. Start quiz contains such a function, and therefore start quiz can be used here because it's then the value stored in this start quiz variable that will be used as a value for onPressed. And that is that function that should then be executed when the button is pressed. And ultimately, it's this switch screen function, of course, because that's the function we're passing around. And with that, we in general have the setup we need to manage the state in that widget, that quiz widget, that is in the end a parent widget of both start screen and question screen, because both these widgets are used inside of the quiz widget. But at the moment, I'm getting an error. Now, this error is related to me having const here, but even if that's removed, we still get an error. We're getting this error here because I'm using switch screen here when initializing this active screen variable. And this basically happens at the same point of time where this method here is created. And therefore it happens too early. Both this variable initialization and this method creation here happens when this class is turned into an object. So you could say these lines here happen almost simultaneously. And therefore here it's too early to reference this switch screen method because essentially it's not guaranteed that it exists yet, you could say. So how can we work around that? Well, the best way of working around that is to add another method here to this quiz state class, and that would be the built-in init state method. If you start typing, you should get these auto suggestions, and if you complete this function here, this method should be added. Now, init state is a method that is in the end provided by this state class, which we are extending, but we can override it to add our own initialization logic. And this indeed is a method that you typically want to add to your state classes, so to your classes that are based on state, to do some extra initialization work when that state object is created for the first time. Init state will execute once after this object has been created, and therefore in here you can indeed use all these variables and also reference this switch screen function, for example. But init state will then never execute thereafter again, which makes this the perfect place for some general initialization work. And therefore it's actually here inside of init state where I want to set active screen equal to start screen switch screen, like this. We don't need to wrap this with set state here, and we shouldn't wrap it with set state because this will execute before the build method runs anyways. So therefore active screen will be set to the right value when the build method executes, because init state will be executed first by Flutter. Therefore you don't need to call set state here because we don't need to run the build method again because it hasn't been executed at all at this point of time. And up here we therefore now set active screen to nothing, and hence you should add a question mark here to make it clear that active screen can also be null. Initially it doesn't have a value because that will only be the case after init state ran. Which of course is also pretty much the case after the object was created, but technically it's not the case right from the very start the object was created. Instead, init state is just called immediately after the object was created, but technically not during the object creation, which is why technically active screen initially is null, which is why you must add this question mark here. And with that, we can now reference switch screen here, because in here all variables and methods will have been initialized and created. You also should keep this super init state call here, because this makes sure that in the parent class, in the state class, init state is executed as well, to allow Flutter to do its additional initialization work that might be performed in that parent class. And with that, if we now save this and force a reload, we see this initial start screen, which proves that setting active screen to start screen here worked, because it is active screen that is then used down there as a child, and if this would be null still, we wouldn't see anything. So the fact that we see something here proves that it works. And if we now click start screen, we switch to the questions screen. This screen only has some dummy content right now, which is why it looks so broken and ugly, but it actually worked. We switched to that screen, and that proves that our logic here works, that we successfully lifted up state. So we rendered content conditionally, and we successfully lifted our state up. And of course for that we had to dive into some new patterns, we had to add a new method here with init state, but I hope it's clear how all these things work together and why the app now works the way it does work. Before we now continue and we, for example, work on the actual questions screen, I want to show you an alternative way of rendering our different screens here conditionally. Currently, we're making sure that different screens are rendered by storing different screens in this active screen variable. This works and you can use this, but this also requires us to add this init state method here, for example, to set active screen to the proper widget. We needed to use init state because we needed to reference switch screen here when storing that initial value in active screen, and this was not possible when initializing it up here, as you learned. That's why it's also worth looking at another solution which will actually allow us to get rid of init state. Instead of storing the active screen in a variable, we could also store some identifier for a screen in here. We could still call the variable active screen, but now instead of storing the widget, we could store a string. For example, start screen as an identifier for the start screen, though this really is up to you. It could be any string identifier. It could even be a number. Every screen could be mapped to a number. But here I'll map screens to strings, since this is a bit more human readable, I'd say. And then in switch screen, we could therefore replace active screen not with a widget, but with another string, which here could be questions-screen. Again, this identifier is also up to you, but both are strings now. Now, what's the advantage of using strings? The advantage is that here we can, of course, initialize active screen to a string. And now we can infer the actual widgets that should be rendered based on these string values. And for that, we can go to the build method, where we need the actual widget that should be output. And down here, as a value for child, we can now use a so-called ternary expression. A ternary expression, in Dart and in many other programming languages as well, is a feature, a concept, which allows you to check a condition and then yield one value if the condition is met and an alternative value if it's not met. And it's written like this. You first define your condition. For example here, that active screen is equal to start screen. And that would be written like this. Active screen equals, with two equal signs, that's important, start screen. Now it's two equal signs instead of one, because here we actually don't want to assign a new value to active screen. That is what you would do with one equal sign. And here would be the wrong place for that, because here a value is wanted, a widget value is wanted, not some assignment operation. And therefore we use two equal signs, because two equal signs are a totally different thing in Dart, and again in many other programming languages as well. Because this is now a comparison operator that checks for equality. This operator will yield true as a value for this overall code if active screen is equal to start screen, and otherwise it yields false. And maybe you remember this slide from the previous course section where I did mention these Boolean values already. It's a special kind of value which is supported by Dart and basically all other programming languages out there in the world, which is either true or false. And this bool type exists almost entirely just for the single reason that often in your code you need to compare values and you must find out whether a certain condition is met, true, or not met, false. So here this code will yield true if active screen currently holds start screen written like this as a string value, and false otherwise. And here, to then turn this into a ternary expression and use this information, whether this is true or false, you then add a question mark, and after this question mark, you then define the value that should be yielded by the overall ternary expression, and that should therefore be used as a value for child if this is true. And here, that would then be the start screen widget, which is created like this, and to which we still pass a pointer to the switch screen method. So just as we used it before somewhere else, now here in the build method, derived conditionally based on this condition. But at the moment in this condition, we only have one value that we use if this condition is met. We also must define the value that should be used if it's not met. And you do that by adding a colon thereafter, and now you define the else case, the value that should be used if this condition yields false, if it's not met. And that value here, in this case, would be my questions screen widget, which can be turned into a const value. Now I formatted the code, and this is now how the overall ternary expression looks like. We have a condition with the double equal sign operator, which yields true or false, and then we have a value that's yielded if this is true, and we have a value that's yielded if this condition is false, so if it's not met. And whichever value is yielded here, so start screen or question screen, is then the value that's passed to this child argument. With that, if you save that and force your app to reload, you should still see that start screen here initially, and when you click this button, it should still switch to the questions screen. So this also works, and that's a different approach for rendering content conditionally. It's up to you which approach you prefer, but this approach has the advantage that it requires a bit less code. Most importantly, it does not require this extra initState function. And I'm showing these different approaches because in different situations you might need different solutions, and of course you also simply might prefer different solutions. Now here I'll stick to this identifier solution, but I want to show you yet another alternative to this ternary expression here. So you can use ternary expressions in your widget tree, for example, to dynamically derive a value based on some condition or based on some other value in the end, therefore, in this case based on the value stored in ActiveScreen. But adding such ternary expressions here in the widget tree can also make the code a bit harder to read. It also might be easy to overlook this. And therefore you might prefer an alternative approach, which I also want to show you. Instead of using this ternary expression down there, you could also go to your build method, which is executed when the widget is rendered for the first time and after setState is called. And in there you could introduce a new variable, which is now only available inside of the build method. So this is now not a class variable. It's not like ActiveScreen, which is available in the entire class, but instead it's a variable scoped to this build method and only available in this build method. And this variable could have a name of screenWidget, though the name as always is up to you. And it could initially be set to startScreen, which still receives the switchScreen function as a value. But now I want to make sure that screenWidget is set to a different value if ActiveScreen is not startScreen but questionsScreen. To achieve this, we could cut this ternary expression and use that up there. And then we could actually even set this to final, because now this never changes. It's only set once whenever the build method runs, either to startScreen or to questionsScreen. And you could then use screenWidget as a value down there for child, so that the value stored in screenWidget is passed as a value to the child argument, and that screenWidget value is derived dynamically with a ternary expression up here. You could do that, but with that you would of course still be using a ternary expression, though now at least outside of the widget tree, which already could be considered to be a bit more readable. But I want to show you a different approach. Hence I'll go back to storing startScreen as an initial value in screenWidget, and I'll set this back to be a variable, because now I conditionally want to set screenWidget to questionsScreen if a certain condition is met. Now for that, first of all, the type here for screenWidget should explicitly be set to widget, so that it's not inferred in a too restrictive way. We did that a couple of lectures ago already, if you recall. But now this code here should be executed conditionally. And for that you can use another keyword provided by Dart, the if keyword. That's a crucial keyword which you need to use a lot, which is why I'm introducing it here, because if allows you to specify a condition between parentheses, and then you add opening and closing curly braces, and the code between these curly braces will then only be executed if this condition is met. So now we could cut this code here and paste this here into this if statement body. And the condition that should be specified here is now almost the same as before in the ternary expression. We want to compare ActiveScreen, so this variable, which is dynamically updated if the button was pressed. We want to check if it's equal to questionsScreen now actually, because we then set screenWidget to questionsScreen if the identifier is equal to questionsScreen. And here we can add const. And with that, whenever the build method executes, the screenWidget variable is initially set to startScreen, but it then might be overwritten if this condition is met here. So if ActiveScreen is questionsScreen, then screenWidget would be overwritten. And that's an alternative pattern of setting content conditionally, because now screenWidget can of course be used down there as a value for child, and therefore it will now either be startScreen or questionsScreen that is set as a value for child. And that's the last alternative I wanted to show you. If we save this and force a reload, the app still works as before, but now using this approach. And as mentioned before, I simply showed all these different approaches because we'll need them from time to time throughout the course. And as a Flutter and Dart developer, you of course must know about these different approaches so that you can solve the different problems you might be facing when working on your own project, or also when working together with other colleagues that might be using one of these approaches. So now that we learned about outputting conditional content, it's time to continue with this app, and here with that questions screen, which of course is far from being finished here. So for that, back in code, in this questions screen file here, in the questions screen Dart file, where we have this questions screen widget, the goal now in the end is to output a question and then a couple of possible answers for this question, where only one answer will be right. And after the user chose an answer, that answer must be stored somewhere so that it can be considered for deriving the final results screen. But immediately after picking an answer, the next question in line should be shown with its answers until there are no more questions and answers left. That's the goal here. So therefore, we need two main things here. We need some widgets here to display the question and the answers, but we also need the questions. And I will start with that. For that, in the lib folder, I actually want to add a new code file because I want to define a class that acts as a blueprint for my question objects. Because I want to set up questions as objects that group the question and the possible answers together into one data structure. Because that's what objects are about in the end, as you learned. They are about grouping related data and logic together. And even though we only used classes to build custom widgets up to this point, we can also use this class feature to create blueprints for all other kinds of objects, like for example these question data structures with which I want to work. That's why I'll add a new code file, and I will actually add that file in a subfolder in that lib folder. So I'll add a new folder in this lib folder, which you can of course also do by using this menu here and then picking new folder. And I'll name that folder models because I want to store my data models in there, the blueprints for the data I'm working with. And in this models folder, in the lib folder, I'll add my quiz_question.dart file. And this is now not a file that will contain a widget, but instead a file that will contain my question blueprint. For that, I'll still use the class keyword because we of course still need to create a class here. And I'll name this class quizQuestion, though that name is up to you. And this will now not extend anything because it will not be a widget and there is nothing else that this class would need to extend. Instead, it's just defined like this. And in this class, you can now define which kind of data you want to store and which kind of additional logic you might want to put in there. And here, for a start, I'll add two final class variables, instance variables, so two properties that should exist on these quiz question objects later. And the first one is the actual question text, which should be of type string, defined like this. And then, as mentioned, I want to have a couple of possible answers, so a collection of answers. And for that, I'll add an answers property, but what could now be the type of that? Well, in the end, it should be a list of answers, a list of strings. And therefore, the proper type here is list, and then a list of strings, utilizing this generic list type, which I did show you a couple of times before in this course already. So that's my answers property. And now in order to set these properties to some values, we also need a constructor function so that we can reuse this class and create different quiz question objects with different texts and different answers based on the same blueprint. Therefore here, just as for our widgets, we add a constructor function that can receive some arguments, which are then mapped to these properties. And for that, I expect to get my text, which is then mapped to this text property by using this text. And as a second argument here in this constructor function, I expect to get my answers list. And here we can now add const, because indeed, once such an object is created in the future, it will not be changed thereafter. At least right now, there is no way of changing this. Hence, we can also allow the creation of const quiz questions. And we do allow this by adding const in front of the constructor function. With that, we got this quiz question class. And now we can add another file, which I'll add in another subfolder in the lib folder, which I'll name data, where I want to store my actual dummy questions, which I want to use for this quiz here. And hence I'll name this file questions.dart. The name is up to you, but in here I now want to define all these questions. And the idea here is to create a questions variable or even a constant, since I don't plan on changing that list of questions as part of this application, which could be named questions. And that should then be a list of such question objects that are created with help of this quiz questions class on which we just worked. For that, in this questions Dart file, we have to import this model file on which we just worked from our project, and there from models, this quiz question Dart file. And then here in this questions list, we can create our quiz questions by simply calling the constructor function and then passing the question text here as a first argument. For example, what are the main building blocks of Flutter UIs? Like this, that could be my question. And then as a second argument to quiz question, we pass a list of answers, a list of answer strings. Because quiz question is defined such that we want to get a list of strings as a second argument. And that list of strings will then be mapped to this answers property as defined in our class. And here we could then have widgets as the first possible answer, components as the second possible answer, blocks as the third possible answer, and functions as the fourth possible answer. And my goal here is to make sure that it's always the first answer that is correct, because we'll need to know which answer was correct for showing an appropriate results screen later, where we inform the user which answer would have been correct and which answer was chosen by the user. And to make sure that we later know which answer was correct, I'll make sure that it's always the first answer in this list of answers that is the correct one. And to make sure that our quiz doesn't become predictable, we'll shuffle these answers before displaying them on the screen. But internally, the correct answer will always be the first one in this list of answers. Well, and now you find a questions.dart file attached, which you should use to replace your file with, because this file, which you find attached, then contains a bunch of example questions, a bunch of dummy questions, which we can use for this demo app here. And I'm providing this file so that you don't have to come up with all these questions and answers and write all these questions and answers on your own. The attached file assumes that we have a quiz question model as defined in this quiz question.dart file. So in order to use these attached questions, you must make sure that your quiz question model looks exactly like mine. So it must have the same name and the same properties. And with that, we got the questions for our app. Now it's time to use them on this questions screen. So in this questions screen, I now want to output these example questions, one after each other. And for that, down here in this questions screen state object, which is where we have this build method, we of course want to output the question text and then below that, the answers to the question. So we have a couple of widgets above each other here. And that of course screams for a column. And this column then has a couple of child widgets passed to it through that children prop here. And the first child at the top should be a text widget, which is used to output the actual question text. So here with this widget, we'll output the question, and we'll use the actual question text soon. Below that question text, I then want to have some spacing and then a couple of buttons where each button represents one selectable answer. So to add the spacing, we can use the good old sized box again and set it to a height of, let's say, 30 maybe. And to get rid of these blue squiggly lines, we can add const in front of this list to make sure that all the items in the list are turned into const items, and therefore they are only stored in memory once and can be reused by Dart, as you learned. And below this sized box, we then need our buttons for the different answers. Now here I want to use the elevated button widget, which is another widget provided by Flutter. And for the moment, I'll just set onPressed to an empty anonymous function. We'll make sure that we do something more useful here later. And now we actually have to remove const here because the button isn't const, and we have to add it manually in front of the widgets that can be const, text and sized box. And for the child here, for this elevated button, we want to use the text widget to output some text as part of the button. So by combining these two widgets, as we did it before, for the text button and the outlined buttons as well in this course. And here the text would be answer 1 for the first button. And of course, this can now be repeated so that we also have a second answer and a third answer and so on. Now, soon this will be generated dynamically to really use the actual answers of the question we selected. For the moment, I'll just hard code it like this. If we now save this and force a reload, and we go to this questions page, it looks like this. And of course, that's not the final look I want to have. Instead, I want to make sure that we take the full available width here for the column. And I again want to make sure that my question and the answers are centered. Now for that, we could use the same approach as we do on the start screen, where we wrap column with a center widget and then set the main axis size on column to main axis size.min. This would work here as well. But to show you also an alternative, we can wrap this column widget with another widget, and that would be the sized box widget. And here I now want to set the width to a special value that will take as much width as is available. So instead of hard coding this to a width of 100 pixels or anything like that, which will probably not be the exact width of the device we're running on, I can use a special value built into Dart, and that's double.infinity. Now that's a special value which simply means use as much width as you can, be as wide as possible. It's built into Dart, and we can use it as a value for width here, and with that you will see that we now at least take the entire width. To center the questions and the answers vertically, we then can use another setting inside of column, and there we can set the main axis alignment. You might remember that for main axis size, I mentioned that the main axis for column is the vertical axis from top to bottom. And hence the main axis alignment also controls the vertical alignment, so whether it's centered or if it's at the top or the end of the vertical axis. And we can set this to one of the built-in values, for example, main axis alignment center. And if we do this and save that, we now see that this is centered. So this is an alternative to using a center widget as a wrapper and setting the main axis size. And one possible advantage of this approach is that you can set the main axis alignment not just to center, but for example also to space around or space between. With space around, for example, the items would be distributed equally across the screen, including the sized widget, which is invisible but also takes up its space. It's not what we need here, but it could be another reason for using main axis alignment in certain situations. Here it's center, which I want though, so that it looks like this. Of course, the colors and so on are not final yet though. And that therefore is the next step. I want to change the question color and of course also the look and styling of my answer buttons. Now for the question color, we can simply add the style argument here to the text widget and set this to a value of type text style with help of the text style constructor function, and set this to a color of white, like this. With that, we got a white text color. So that wasn't too special. But for the buttons here, I now want to make sure that I can style them such that I don't have to copy and paste the same style to all my buttons. Because at the moment here, I have 3 buttons, and if I want to apply some style here, for example to the first button, I can of course do that with the style argument, and then by using elevated button style from, as we also did it for the outlined button on the start screen, for example, but I would have to repeat that for all my buttons here. And that quickly gets annoying, and if I ever want to change the styling, I also have to do that for all buttons. And that's why this here is a great example and a great use case for creating another custom widget, so that we have another reusable building block that has this styling that we want for our buttons built in. And for that, I'll add another file here in my lib folder, and I'll name it answer button.dart, like this. And in there, we can create a new class, answer button. And here, since I want to build a widget, I will extend one of the widget classes. And for this button, I can extend the stateless widget class, because even though it's a button that can be tapped, I have no state that would need to be managed inside of that button. Therefore, it's a stateless widget. And of course, as always, we import Flutter material Dart here. And we add this build method as we always do, accepting this context argument with or without this type annotation, doesn't matter. And then inside of the body of this build method, we return our widget or combination of widgets. And in my case, it's this elevated button which I want to return there. So I cut this from questions screen and instead return this here with a semicolon at the end. And now we'll be able to set up our styling here and then reuse this answer button in the questions screen. So in this column here, we'll be able to use the answer button a couple of times. And all these buttons will then have the same styling because the styling is locked into our custom widget. That's the plan. Now, of course, the text that's set on this button should be set from outside this button, though. It should not be locked into this button. And of course, you might already know how this works, because you learned how to make your widgets configurable in the previous course section as well. We can add a constructor function here, answer button, and a property, in this case the answer text, for example, which should be a string. And then here in this constructor function, we can accept and set the answer text argument, and also accept and forward that key argument here, this named key argument. And then we can use answer text, which we get as an argument and which we store in this class variable, down there as a value for this text, so that this text is actually set from outside this widget. This now can't be const anymore, though, because answer text is now a variable. Actually one that doesn't change, but still. The text widget can no longer be used in conjunction with the const keyword here. That's not all I want to accept here, though. Instead, this function, which is set as a value for onPressed on the button, should also be coming from outside, so should also be settable from inside questions screen, so that we can then in the end pass our answer text to this answer widget, and then as a second argument also our function that should be executed when the button is pressed, for example. And to achieve this, we must accept another argument, a positional or named argument, that is up to you, as part of this answer button. And for that, I'll add another property here, which should be of type function that actually returns no value. So I want to get a function that returns no value. And I'll name this one here onTap. The name is up to you, though. And accept another argument, which is also named onTap, and which is then automatically used as a value for this property by adding this dot in front of it. And then it's this onTap variable that can be used as a value for onPressed here. OnTapped is the function which we receive as an argument and which we then use as a value for onPressed on the elevated button, and therefore we'll be able to pass a function here to the answer widget when we use it in another widget, like here in questions screen, so that we can define which function should in the end be executed when this button is pressed from inside the widget where we use our custom answer widget. And of course, all these positional arguments here could also be set up as named arguments. And just to also show you how this would work, I'll actually convert these positional to named arguments, not because you have to, but because it can be interesting to see how this could be done. You simply place these arguments between these curly braces in your argument list here then. And now you must add required, the extra required keyword in front of them, because by default in Dart, named arguments are optional, but here we need values to make sure that this answer button widget works correctly, and therefore we must make them non-optional by adding the required keyword in front of the named arguments. Besides that, they now work like positional arguments. They can receive values, and these values are then forwarded, thanks to the this keyword, to the properties that have the same names. So answer text to answer text and onTap to onTap. Now we can turn this into a const constructor function. This is possible here now for this widget. And therefore now in questions screen, we can use this widget by first of all adding an import, where we import from advanced basics and then from answer button.dart. And with this import added down here, you can now use this answer button widget. And since I'm now expecting named arguments here, you have to target these arguments by name. So answer text and onTap. And you could also change the order here now, because for named arguments, this order is not important. It's just important that you set all required arguments and that you target those arguments by their name. That being said, I'll go back to the other order because that makes a bit more sense for me here. And with that, we now could reuse this answer button here for answer 1 and answer 2 and answer 3. But of course, we haven't changed the styling yet. So that's what I'll do next. Now to change the styling, I'll go back to my answer button widget here. And there I already added the style argument to elevated button. And I'm using the style from method on elevated button to easily generate such a style object. But now we need to pass some arguments to style from to really change the styling. And for me, that changes with the background color of these buttons. Here I want to use a color, maybe some purple color, but actually I'll use that color picker again to pick a dark bluish purple color here maybe. Something like this. And we can now add const in front of that. And I also want to change the foreground color, so the text color, and set this simply to white, like this. If we now save that, all buttons have this style, even though we changed it just in one place, because we did it in our custom widget, which we're reusing a couple of times. Now that's a good start, but I actually also want to change the shape of these buttons a little bit. And for that, we can set the shape argument here, still in this style from method, and set this to a specific shape that is actually also suggested here if I open this suggestion menu by pressing Ctrl space. And here it's this rounded rectangle border shape which I want. With this constructor function, I can create a configuration object for my buttons that allows me to add some nicely rounded corners to the button. For that, this rounded rectangle border constructor function wants a border radius argument, which can be set to border radius circular using another class and constructor function provided by Flutter. All these things here are provided by Flutter. And border radius circular simply adds some rounded corners, and you can set the radius, and you can simply try out different numbers here, but 40 should achieve the look which I want to have here for this application. With that, if we save this, we have some nice rounded off corners, and the buttons should now look something like this. And now I just want to add more padding, so more internal spacing between the text and the borders of that button. So that padding here should be increased. And that can also be done with this style object. In there, anywhere in this style from method, you can add the padding argument and set this to a value with the edge insets class provided by Flutter. And you could use edge insets all to apply the same padding in all directions. But here I actually want to have different horizontal and vertical padding, and this can be achieved by using the special symmetric constructor function. This constructor function allows you to set separate paddings for horizontal and vertical padding. And here for vertical padding, so top and bottom, I want to have a value of 10 and set horizontal to 40 maybe. And now we can add const in front of this. And if you now save this, the buttons should look like that. And of course you can also change them, tweak this a bit more to your liking, but of course keep in mind that this is all just some dummy text right now, which will soon be replaced with the actual question text and the actual answers. But for me right now, that is the look I want to have, and I'll tweak it a bit more later. But as a next step, I'd actually like to use the actual question text and the actual answers that we prepared in this questions Dart file. So now the goal is to output the actual question data, the actual question text, and its answers on this screen. Now for that, we of course got our questions list here in this questions Dart file. But how do we now output the texts and the answers for these different questions in this questions screen widget now? Well, we can start by importing the questions into this file. That's a good start because that at least allows us to use this list in this file. So for this, we can add an import here where we import from our own project, and they are from the data folder and they are from the questions Dart file. And with this import added, we can access this questions list here. Now we just need to access the different elements in that questions list. And therefore, it's important to understand how you can access list values in Dart. And for that, let's take a simple example, a list of hobbies, a list of strings, therefore. And let's say in some place of your code, you want to access the first element in this list, so cooking in this case. This could be done by using this notation. This special notation here allows you to use a list index starting at 0 to access the different list items. So since this list index starts at 0, you would use this notation to access the first list item and this notation to access the second list item. So the first item in a list has an index of 0, the second item has an index of 1, and so on. And this index can be used with this special square bracket notation after the name of the list, so after the name of the variable or constant that contains the list, to be precise, to access the different list values. And if you would try to use an index that doesn't exist, so in this case, for example, the index 2 for a list that only has 2 elements, you would get an error. So you can't access elements that aren't there, which hopefully makes sense. Now for us, this means that we can, for example, access the first question in this list of questions by using this questions constant and then access the element with an index of 0. So in our questions screen widget here, in the build method, we can get our current question, for example, which is stored in a final variable here, since I don't plan on reassigning it inside of this build method, by accessing questions, which is this questions list here. So it's named questions here in this file, which we are importing. Hence, I can reference this list by its name here in my code in that file where I have that import. And the first question then would be accessed like this, with square brackets 0. That accesses the element with an index of 0 in that list of questions. And now we could use this current question here to output the text instead of this placeholder text. For that, we can use current question, this variable, which holds this question. And now it's important to keep in mind that our questions are objects created with help of this class constructor function. And in Dart, you can access data stored in objects by using the dot notation, which you also already saw from time to time in this course. By adding a dot after a variable or constant that contains an object, you can access the available data properties and methods that exist on this object. In this case, I could access the answers, but I can also access the text of this question. Now, this can't be const anymore here. We have to remove const because this is now derived dynamically, but at least the text style can still be set to const. And we can now, of course, also set our answers dynamically here. For that, for the first answer button, we can access current question.answers. And now answers is yet another list. So of course here we can again use this square bracket notation to access the first answer. And then for answer 2, to access the second answer by using the index 1. And that can be repeated, of course. We can do this for the third answer here, and then add a fourth answer by accessing the answer with index 3. And if you do that and save everything, you will see that you got your question here and then your different answers. And that is indeed how you can access this question data. Though that's not entirely how I want to use that data. Because, for example, with this solution, I manually created all these answer buttons, which is a lot of unnecessary code duplication. And as developers, we typically try to avoid code duplication because that then makes it easier for us to change things in the future. And it also has the disadvantage that if we had a question that had more than 4 answers, which is not the case here, but which we could of course have, then we would not have enough answer buttons here. Or we would have some empty answer buttons for questions that have less than 4 answers. So hard coding these answer buttons here is not ideal. And that's why we will output these buttons differently in the next lecture. The goal now is to generate these answer buttons here dynamically based on the actual amount of answers that we have for the current question. And by the way, later we will of course also make sure that the question changes once it has been answered. But for the moment, we just want to output these answer buttons dynamically. And this can be done by going to our children list here in this column. And then in there, we can access current question.answers, which is this list of strings. And now we must convert these strings to widgets, so to say, to widgets that then use these strings. And such a conversion can be done by using Dart's built-in map method. Now, for that, it's important to understand that answers is a list. It's a list of strings. And lists, no matter which kind of values they contain, but lists in general in Dart have a broad variety of built-in methods, built-in functions that can be called on them. And these functions simply interact with the list in different ways. For example, add would allow you to add a new item to that list. Something we'll also use later in the course. Map allows you to convert, to transform, you could say, the values in a list to other values. For that, map takes a function as a value. So that's another example for a place where a function is used as a value. And this function which you pass to map will be executed automatically by Dart for every list item. So Dart automatically goes through the entire list and executes this function on every list item. Now Dart will then also automatically pass the list item for which it is currently executing this function here as an argument to this function. So here you get the list item for which this function is currently being executed. And inside of the function body, you then can return the transformed item, so the new value you want to have in the list instead of that old item. And of course, that new value which you return here can and typically will be based on this item on which the function was called and which you receive as an argument here, because that then allows you to basically replace all the items in a list with new items that are based on the old items. And here I want to return my answer button widget, so that I convert this list of answers, this list of strings, to a list of answer buttons. And since widgets are in the end just objects, which are totally normal values in Dart, it's absolutely fine to convert a list of strings to a list of widgets, even though it might sound strange at first. Now it's important to understand that this conversion does not change the original list. So the list of answers that is stored in these quiz question objects does not change when calling map here. Instead, map in the end yields a new list, a brand new list object in memory, but both lists coexist in memory. That's really important to understand. Map does not change the original list. Instead, it returns a new list full of new objects. In this case, full of new answer buttons, and on these answer buttons we can of course then set answer text to item, because item here will be of type string, since our answers are strings in that list of strings. So item is our string. We could also name it answer instead of item, because that name is up to you. To make it clearer, that we'll get the individual answers here, since this function is executed for all the answers automatically by Dart. And hence we can set this answer string as a value for the answer text, which wants a string. And for on tap, we can, for the moment, just pass an empty anonymous function. But now you see I'm getting an error here. And in the end, I'm getting an error here that this element, which is of type iterable, whatever that may be, can't be assigned to the list type widget. The problem which we in the end have here is that I now got a list of answer buttons, or something like a list. It's actually an iterable as it turns out, but you can treat this almost like a list here. But Flutter isn't happy with getting a list or an iterable here. And that would also be the case if I manually create a list here, a list of answer buttons, for example. Here I also would be getting an error that this type of data is not wanted here. And it's not wanted here because children, this argument which we set on the column here, wants a list of widget. Now here inside of that list that we are creating another list though, a nested list. So now children is a list of widgets like text and size box, but also a list that contains other lists as values, and that's simply not what children wants. It wants just widgets as values inside this list, not other lists. So converting our answers to answer buttons is not enough if they're still in a list thereafter. Instead, what we have to do here is something called spreading. We have to spread this list or this iterable, which is generated by map, into a couple of individual values. And that's done by adding 3 dots in front of this, which might look strange, but which is another built-in operator, a built-in keyword, you could say, which is available in Dart. And these 3 dots will simply take all the values in a list or an iterable and pull them out of the list, pull them out of the iterable, and instead place them as comma-separated values in this place in code here. So now these answer buttons in this list of answer buttons here are pulled out and added as individual comma-separated answer buttons to this list here, which is set as a value for children. That is what's happening here with this code. And with that, we can and should now get rid of these extra answer buttons here and just use these answer buttons here, which are created based on the answers list, which is a list of strings, which is then converted with help of map from a list of strings to a list of answer buttons, and then these answer buttons are pulled out and added as individual elements to this children list, so that overall here we get a list of widgets. And with that, if you save everything, you see that again here we have all these answers like before, but now they're dynamically generated instead of being hard-coded. And this is a super important pattern because being able to dynamically generate and output list content is crucial, since you will see that most apps deal with some kind of list data in some parts. So now that we're deriving these answer buttons dynamically based on the actual answers in our list of answers here, there are 3 things I want to change regarding these answers. For one, the styling. I'd like to make sure that these answer buttons take up all the available space, leaving some empty space to the left and right. That would be nice. In addition, I want to shuffle them because, as mentioned earlier, it's the first answer that is the correct one, and knowing this will be important for later presenting the results. But for showing the answers, I actually want to shuffle them so that it's not always the first one that's correct. And third, I of course want to make sure that when we tap those answers, we proceed to the next question, or after going through all questions, to the result screen. Now let's start with laying these things out correctly. To make sure that these answers take all the available space, we can go to the column widget here. And besides setting the main axis alignment, we can also set the cross-axis alignment. The main axis in a column is the vertical axis, the cross-axis is the horizontal axis therefore. And if you set this to cross-axis alignment stretch, which is a built-in alignment option for the cross-axis, the items inside of the column will actually stretch out to be as wide as possible to fill the entire column width. But of course that now also means, as you can see, that there is absolutely no space left to the left and right, and that's also not what I want here. To make sure that there is some space left, we therefore have to add some padding or margin around the column. And here it won't really make a difference which of the 2 things we use here. In theory, a padding is the internal spacing between content and the borders. As we have it here for the button, that would be the padding. And the spacing between widgets, so this spacing here for example, would be the margin around the widget. Now visually it here doesn't matter what we set for the entire column to add some spacing around it. And therefore here I'll go for a margin by picking this column here and refactoring this to wrap it with another widget, with the container widget, because that container widget then has a margin argument that can be set. And margin, like padding, which you already saw earlier, takes this edge insets class here provided by Flutter. And with edge insets all, we can add the same margin in all directions. So top, bottom, left, right. And here we could set this to 20. And that can also be turned into a constant value thereafter. So with that, we now have some spacing. Maybe I'll actually use 40 here. Yeah, looks nicer. And I also want to center this text here. And to do that, we can go to this text widget, and there on the text, not on the text style, but the text itself, you can set a text align argument, which then can, for example, be set to text align.center to, as you might guess, center the text in the middle horizontally, so that now it is centered. So that's now the visual part. And I'll get back to this text here, for example, later again, but for now I'm quite happy with how this looks. But of course the answers are still not shuffled, and that's therefore what we'll tackle next. So how can we shuffle these list items here? Well, that, thankfully, is easy enough to do, because Flutter gives you a shuffle method that can be called on lists. So just as map could be called on lists, shuffle can also be called on lists. It's a built-in method that can be called on lists to change the order of the items in the list. However, what's important to understand regarding shuffle is that unlike map, it does change the original list. Map does not change the original list, shuffle does. And I actually don't want to change this list of answers. I want to make sure that the correct answer stays the first answer here. And therefore we have to first copy this list before we shuffle it. Otherwise, finding out which answer was the correct answer will be impossible after these answers have been shuffled. So therefore here, to make sure that we're shuffling the answers in a brand new list, we can go to this quiz question class which we added earlier, which is our blueprint for these questions. And in there, we can add a function, a method, that could be called getShuffledAnswers, like this. This should return a list of string values, so the same data type as we used it here for answers. And inside of getShuffledAnswers, I therefore want to call this shuffle method on answers, but I first want to create a copy of answers. And creating such a copy is thankfully straightforward. We can use the built-in list class. So list is not just a type, but also a class built into Dart. And this offers a couple of utility constructor functions that make it easy to create different lists. For example, it has an auth constructor function. And this auth constructor function creates a new list based on another list. So it copies an existing list basically. And therefore here we can pass answers to list auth to create a new list based on that old list of answers. And then we can call shuffle on this new list. So now the new list will be the shuffled one and the old list will be untouched because we copy the list and then shuffle the copied list. And what we're doing here, by the way, is called chaining. We're calling a method on the result of calling another function or method. And this is something you'll see quite a lot when working with Dart and Flutter. It is quite common to chain command after command after command. Now here it's of course not enough to just shuffle the list though, instead we also must return it. And here it turns out that shuffle indeed returns nothing. So shuffle does not yield the shuffled list, instead it shuffles the list on which you call it in place and does not give you the updated list. Therefore here to get hold of that updated list, we actually have to change the code a little bit and first create a new final variable, which could be called shuffled list, which is initially just the copy of the list. But then we call shuffle on that shuffled list. And then it's this shuffled list here, which is returned. And we must do it like this so that we first create this copy and store this copy in a variable. And then we call shuffle, which as mentioned, changes that list in place. So after this line of code, shuffled list will have changed. And then we return the updated shuffle list. And you might wonder how a shuffled list can change if it's final, but final only ensures that you can't reassign the variable. So I can't, for example, assign shuffled list to a new list here. This does not work because of final. But that's not what we're doing when calling shuffle here. Instead, this reaches out to the existing list object in memory and edits the items in that list. It does not overwrite the list as a whole. So calling shuffle here does not violate final because we're not reassigning a value to shuffled list. We're just editing an existing value in memory with shuffle. And with that, we now got our getShuffledAnswers method here. And back in questions screen, we can now use these shuffled answers. We can use them down here. Instead of accessing current question answers, we can access current question, get shuffled answers, and then map those shuffled answers to our answer buttons. So this logic doesn't change. We still chain this map method here onto the getShuffledAnswers method. But the difference now is that we map our shuffled answers. And, very important, we do all these things without changing the original answers list. With that, you'll see that now I have a different order than I did before. Before, widgets was at the top, because this is the right answer. Now here, for me, it's functions, and the next time I'll visit this page, it will likely look different again. Now, with those shuffled answers being displayed here, it's time to make sure that once we select an answer, we move on to the next answer in line. And to do that, we must make sure that this question index here changes over time. Because this question index here determines which question is our current question, which then determines which question text and which question answers are shown on the screen. So how can we change this index? Well, by managing it as state again. And that's why I created questions screen as a stateful widget, so that we can manage and change state in there. We should now add a new variable here in this questions screen state class. And that could be the current question index. The name is up to you, but of course it should describe which kind of value will be stored inside of it. Now initially, this should probably be set to 0, so that we start with the first question in our list of questions. But it should then change whenever we click one of these answer buttons. Therefore, we also must add a method to this questions screen state class here. And that method could be called answer question, because that is what we're in the end doing when we click one of these answer buttons. We answer the question. And as a result of doing that, we want to move on to the next question. But of course, later, we also want to make sure that we store the answer that was picked. So therefore, here we have the answer question function, which doesn't return anything. And in there, I want to increase current question index by 1. Now, this can be done by setting current question index equal to current question index plus 1. This might look strange at first, but you can access the variable, which you then set on the left side of the equal sign, also on the right side of that equal sign, to derive the new value to which it should be set. Because that right side will actually be executed first. So here, when this line of code executes, Dart will first take a look at current question index, here on the right side of the equal sign, and take the value that's currently stored in there. Initially, that will be 0. It will then add 1 to it, so that overall, for the first time this function is executed, we would have a value of 1 here. And then this new value is stored back into this variable. So that is how we can increment this variable. And since this is something you will find yourself doing quite often in code, Dart actually also gives you a shortcut for this. Instead of writing it like this, which you can do, but which is a bit long, you can also set current question index plus equal 1. This code is equal to this code. By using this plus equal operator, you're telling Dart that you want to set this variable equal to its current value plus 1. So this is simply a shortcut for this. And if you want to increment the value by 1, there's an even shorter syntax, because you can then also just set current question index plus plus. This increments the value by 1, and only by 1. So if you want to add 2 to that value, this syntax could not be used. This syntax could be used though. But if it's 1 that you want to add, you can use this syntax, this code, for doing that. And a similar syntax would also exist for deducting 1 by using minus minus, or here in this case, minus equals. And that's not just the case in Dart. Instead, you find these syntaxes in most programming languages. So this will add 1 to the current question index. And now we can use the current question index here instead of hard coding 0 inside of the build method to access the question with that index here. Now, of course, at the moment, the build method would never execute again though, because as you learned before, you must call setState, the setState function provided by Flutter, in order to tell Flutter that the build method should be executed again. So that's the correct way of updating current question index. And with that, the next step is to make sure that this answer question method here is actually executed when our button here is clicked. Now, to achieve this, we just have to replace this empty anonymous function, which I used as a dummy value for my onTap argument here, which wants a function, with a pointer at this brand new answer question function, which we just added. As you learned, without parentheses, because we want to point at that function and pass the function as a value to onTap. And with this, if we now save this all, we should be able to click this and move between those answers. So that's working as it should. Of course, at some point we'll reach an error here, because at some point we try to move on to a question that doesn't exist, because we never stop incrementing this current question index. But we will of course take care of that soon as well. So at this point in the section, we can start the quiz, and we can move between our questions here by answering them. And you might notice that some answers look quite ugly because the text is not centered. Basically, all answers that span multiple lines are not centered. And that is something I want to change. And I also want to change how this question text here looks like, because I think it could stand out a bit more. But let's start with centering this text. To center this, we can go to our answer button widget, and there we have this elevated button, which has this child widget here, which is the text widget that is responsible for displaying the text in this button. And of course here we can add text align as we did it for the question text a couple of lectures ago. And we can set text align to textalign.center here to make sure that all text is centered. So that's one thing. Now regarding this question text here, I want to do two things. I want to make it a bit bigger and bold, but I also want to use a different font family. So my next goal is to adjust the styling of this text here, the question text. And as mentioned, I want to use a different font family for this text as well. Now, if you don't want to use the default font here, as we're currently doing it, there are different ways of adding custom fonts. And attached you find a link which would explain you how you could add custom fonts by importing font files manually into your project folder, how you could then register these font files in your pubspec folder and then use them in code. You can do that, but one of the easiest ways of adding custom fonts to Flutter projects is by using Google Fonts and the special Flutter Google Fonts package, which you can add to your project. Now, Google Fonts is, of course, a very popular collection of fonts that you can use in all kinds of projects, and adding them to Flutter is super easy because of this official Google Fonts package, which you can add to your project. Now, attached you also find a link to this package here, where you can learn more about the package and how to get started with it. But of course, in this lecture, we're also going to add and use it together. Now, adding extra packages to Flutter projects is something you'll typically do quite a lot when building Flutter apps, because there are different packages for all kinds of things, and you will see various extra third-party packages being added to Flutter projects throughout this course. This pub.dev site is the official Dart package site, which is used for hosting and listing all those third-party packages which you could add. And for every package, you find an entry that looks something like this, where you got a README site with various pieces of information about this package, where you find a changelog telling you what changed with the latest versions of that package that have been released. where you might find some examples and where you find some installation instructions. And that's now the important part for us here, because as a first step, we'll have to install this package. And this can be done by copying this command here, which you see here. With that copied in your project, you should open your terminal, and in Visual Studio Code, you can open this terminal by going to View, Appearance, Panel. And this is then your default system terminal just integrated into Visual Studio Code and already navigated into this project folder. And there you can now run this command which you just copied from this package site. In this case, flutter pub add Google Fonts. Now this command will now install this package into this project. And as part of this installation process, once it's done running that installation process, it will also edit the pubspec.yaml file. In that file, you should now find this new package added here under dependencies. So here's dependencies, and nested below dependencies, you find this new package with its latest version, which of course might be a different version at the point of time you're viewing this. Now with this added, we can use it, and you'll learn how to use it here in this README part of the package page, but thankfully using it is also super simple. In the end, you go to the text widget where you want to use one of these Google fonts. So here for me, for example, that's in the questions screen widget, and there it's this text widget here. And you replace the existing style object here with a new object that is imported from this Google Fonts package. For this, of course, you must add an import at the top, where you import from this Google Fonts package, and there from the Google Fonts Dart file. This must be added in order to use these Google Fonts package features in this file. And with that import added down here, where I just removed this style object, you can now use Google Fonts dot, and then you have a broad variety of methods here, a broad variety of constructor functions to be precise, where these different functions map to different font families. And you can visit fonts.google.com to get an overview of all these available font families and to find their names. And for example, for me here, I want to use this Lato font here. And in order to do that, I therefore access Google Fonts .lato and execute this like a function. And this then allows you to again set all these values you could have set on that text style object before as well. So for example, to apply a text color. But in addition to those settings, it will now also apply this font family. So the Lato font family in my case here. And here, in addition to setting this text to be white, I also want to change the font size and set this to maybe 24 and change the font weight here and set this to font weight.bold, which is one of the predefined font weight values you can use because the font weight argument wants a font weight value. With that, if we save this, you now see that the question text looks differently, that a different font is used, and that it's a bit bigger. Now I also want to tweak the color a little bit, and for that I'll hover over colors white, and I'll pick some light purplish color. Maybe like this. Yeah, I think that looks a bit nicer now. I'll just also turn this into a const value here. And with that, you now also know how you can add third-party packages and how you can change the font families. Of course, you can now not just do this here for this question text, but we could also do it on the start screen, for example, for this text here, learn Flutter the fun way. We could replace text style here also with Google Fonts. For that, of course, we must import package Google Fonts and there the Google Fonts Dart file. And then here maybe also use the Lato font or whichever font family you want to use. Now this just can't be const anymore, and instead it's just the color that can be set to a const value now. Because these Google Fonts objects, which are created with these font family constructor functions, are actually not marked as const constructors, and therefore you can't use const in front of the text widget anymore. So with that, if you force a reload, you now also see a different font family being used here for this text on the starting page. So now that we added the Google Fonts package and we changed some fonts here, it's now time to make sure that as we navigate through these questions, we also save the answers that were chosen by the user so that we can then later use them on the result screen. And of course, we should make sure that we stop once we run out of questions so that we don't see this error here. Instead, it is indeed, in this case here, that we ran out of questions, that we exhausted all questions, where we want to show the result screen instead of trying to load the next question. So therefore, we have two main things to do. We must store the selected answers, and we must make sure that we show a different screen once we went through all the answers. And the question is, how do we do that? Well, we got our questions screen widget here with its state class. And in there we have this answer question function, which is executed whenever we click one of our answer buttons. Here we connect this button to the answer question. Now here we then increment the current question index, but it's in the end also here where we should store the selected answers and make sure that we don't continue incrementing this question index until we run out of questions. And therefore, I'd say it's the quiz.dart file with its quiz widget and the quiz state that is important for us here. Because for one, in here, we manage which screen is currently shown. And therefore, that should also be the class where we make sure that the result screen, which we have yet to add, is shown once we're done. And this also should be the place where we store the selected answers, because it's the quiz state class that has access to both the questions screen, which is where the questions and answers are presented, and soon also to the results screen, which is where the selected answers will be needed. So we should lift state up and manage the selected answers state in this quiz state class, since this state class here has access to the screen that generates the answers and soon also to the screen that needs the answers. So therefore here, it makes sense to add a new piece of state, a new variable to this state class here. And this variable here can be named selected answers. And this should be a list of the answers that have been chosen by the user. And the first answer that's about to be added to this list should be the answer chosen for the first question. The second item that's added to this list should be the answer that was chosen for the second question, and so on. Now, therefore, of course, we want to make sure that here we have a list of string values. Hence, we should explicitly set selected answers to that type, so that this here will be an empty list initially, but will be a list of strings once we start adding elements to that list, which we'll do soon. And we can also set this to be a final variable, because indeed I don't plan on reassigning this variable. Instead, I plan on adding elements to the existing list. And as mentioned a couple of lectures ago, that is indeed something you can do with lists and objects. You can manipulate them in memory. Final only complains if you try to assign a new value to this variable, which I won't do. I will just edit the existing value in memory. But of course, initially here, it's empty, and we therefore must now add a method to this quiz state class that is able to add answers to the selected answers list. And for that here, we can add another new method to this quiz state class, which could be named chooseAnswer. The name is up to you, but here I expect to get the selected answer, which should be of type string. And then inside of this function body, I want to update my selected answers here. And for that, we can reach out to the selected answers variable here and call the add method on that. Now that's another built-in method which is available by default in Dart on all lists. And add does what the name implies. It adds a new item to the list without reassigning that variable. Instead, it reaches out to that list object in memory and adds a new item to that object. Which is why we can do it despite this being final, because we're not reassigning the variable, we're just editing the existing list in memory. And here it's the answer which I want to add to selected answers. So now with that, we have a way of storing those selected answers. But of course now we must find a way of ensuring that choose answer gets executed whenever an answer gets picked in the question screen widget. Well, and to achieve this, we have to do what we did before in this course already. We have to pass choose answer as a value to questions screen. So here we can use choose answer by its name without parentheses to pass a pointer to that function to questions screen. And in questions screen, we now must accept this function. For that here, in the questions screen widget, and that's important, we're now in the widget class, not in the state class. So in this widget here, you can add a new final variable of type void function that actually now does take an argument, an answer of type string, and you can name this function variable here on select answer. This name is up to you, but I'm using this way of naming it on something to make it clear that this in the end is a function that's triggered upon a certain event. I'm using this because here I also want to use a named argument again, and therefore here I can set this named argument like this, required this on select answer, and using this on naming here simply makes it a bit clearer that here a function should be passed in as a value without having to look at the type, because for all these built-in widgets, like these buttons, Flutter also uses this convention of naming the arguments that want functions on something. And that's why I'm also doing this myself here for this named argument where I want a function. And I want a function of this type. A function that returns nothing, but that takes one positional argument, which is of type string. So here in Quiz Dart, I now have to pass choose answer as a value for this named argument. So here we can now set this on select answer argument, which we just added, and set this equal to choose answer. Now we have to get rid of const here, because that's not supported anymore. But with that, we're forwarding this function here, which is defined in quiz state, to questions screen. Now in questions screen, we now have the problem, though, that onSelect answer is available in this question screen widget class, but we actually need it in the state class. Because since this is a stateful widget, it's split out across two classes, as you learned. So how can we get hold of a property that belongs to the widget class inside of this state class? Because it is in the end here in this answer question method inside of question screen state where I want to execute on select answer. Well, for that, Flutter gives you a special widget property which you can use in this state class. So in that class that extends state. This instance variable called widget, so this property called widget, is provided by Flutter. It's built into this state class, and you can therefore also use it in your class that extends the state class. And this will give you access to the widget class and its properties. So for example, to onSelect answer here. And therefore here inside of answer question, besides updating the question index, we can now call widget onSelect answer here and pass our answer to this method. Now for that, of course, we need to find out what our answer is. And for that, answer question in here should also accept this selected answer so that we can then forwarded to onSelect answer. And therefore, in the end, to this choose answer method here in the quiz widget, in the quiz state class of that quiz widget. So we have a chain of functions here that need to work together to make sure that the selected answer is passed to the topmost widget that needs it when one of these answer buttons was clicked. Now at the moment, answer question doesn't get this string here though. We want to get a string here, but in the place where we're using answer question, it won't get this string. Because onTap on the answer button actually wants a function that gets no argument. And answer question now does get an argument. So here in this place, to make sure that we do pass a string value to answer question, we should actually replace this pointer at answer question here with an anonymous function that's instead passed as a value to onTap. And in here, we do indeed have access to the answer for which this answer button was rendered. Because keep in mind, we're going through all the answers here, and then we're creating one answer button per answer. That is what map does here in the end, as you learned. So therefore here, we have access to the answer for which this button is created. And in this anonymous function, which is created on the fly here, as part of creating this answer button, so to say, we can therefore call answer question and pass the answer here to answer question. And this will be different for every button. So it will be just the answer that belongs to the button when that button is created as part of this map function. So we make sure that it's really the right answer that belongs to a selected button when a button is clicked. Now this might look like we are now again executing a function immediately, when before we actually passed a pointer at a function here as a value to onTap, but that's not what we're doing here. Instead, we're creating this anonymous function on the fly here, and it's this anonymous function that is forwarded as a value to onTap. And that function body inside of this anonymous function will only be executed when that anonymous function is triggered from inside answer button. So the code here inside this anonymous function does not execute immediately when this button is created, but only when this anonymous function is triggered from inside the button, which here will only be the case when this elevated button is tapped. So at that point of time when that button is tapped, answer question will be called, and the answer of the button that was tapped will be passed as a value to answer question. And in there, we then kind of forward it to the parent widget of the questions screen by executing onSelectAnswer, which was this function we receive as an argument in the questions screen widget. And that in turn is this chooseAnswer function here, because that is what we're passing as a value for onSelectAnswer to questions screen. Now this combination of widget and chain of function calls can be confusing at first, but in the end we're just passing functions as values around, ensuring that we're executing the right function in the right place, and we can still pass data between those different levels of widgets. And with that, with every question that we answer, we'll add a new answer to this selected answers list here. So with that, we're storing all these answers, but now we also must make sure that at a certain point of time we don't continue presenting questions, because otherwise we'll run into an error again once we run out of questions. And to make sure that we don't reach this page, we can actually use this selected answers list here to find out at which point of time we have actually answered all available questions. Because of course, here we add one answer per question to selected answers. Initially it's an empty list, and at some point it will have as many answers as we have questions in this app. Therefore, what we can do inside of this choose answer question here is we can add an if statement, about which you learned a little bit earlier already, and compare the length of selected answers to the length of questions. And if the two are equal, we know that we have answered as many questions as we have. So it's then at this point of time where we should stop. So to make that comparison here, we can access selected answers. And then on this list object here, we got various utility properties and methods, as you learned. For example, we have a length property, which gives us the amount of items stored in that list. And we can check if that is equal to questions.length. Now for this, we must make sure that the questions defined in this questions.dart file are available in this quiz.dart file, and that's of course done by importing them. By importing from package advanced basics, and then there from the data folder, and there from questions.dart. With that, we import this list of questions from that file, and in quiz.dart we can now compare these two lengths. And if they are equal, we know that we ran out of questions. So that's when we want to switch to the results screen. At the moment I have no results screen though, therefore right now I simply want to switch back to the start screen. Hence in here we can call setState to trigger the build method again. And in this anonymous function which we pass to setState, we can set the active screen back to start screen, to make sure that we show the start screen instead of an error once we ran out of questions. With that, if you save this and force the app to reload, you should be able to start the quiz and answer these questions by picking any answers. But once you're done, you're back here on the starting screen, instead of getting that error which we got before. Now what you'll notice is that if you now start the quiz again, and you go through all questions, you will get this error screen again. And we get this error because we don't reset our selected answers. Therefore, we'll actually have more answers than questions, and this condition will never be met again after it was met for the first time. And we could work around that by simply resetting our selected answers back to an empty list. For this, we now just have to switch from final to var, or since I'm defining the type here, actually just remove final, since this will then automatically turn this back to a variable, because we can only set this to a new value with the equal sign operator if this is a variable. That's what I mentioned before. So with this switched back to a variable, once we exhausted our questions here, we should reset selected answers back to an empty list. And with that, if you now save this and force a restart, you can start the quiz again, go through all questions, and if you now start again, you can go through them again without running into an error. Of course, that's not the final version of the app. The results screen is still missing, but that's how we can use this selected answers state to show a different screen once all questions have been answered. So now that we have this starting screen and then the questions screen with all these questions, it's time to also add a results screen, which should look like this. The goal with this screen is to simply show a summary of all the questions that have been answered. The user should see how many questions have been answered correctly, and then they should simply see a list of all those questions with a clear indicator that shows whether a question has been answered correctly or not, and with the correct answer next to the answer that has been chosen by the user. This list of questions here also should be scrollable, since it shouldn't occupy the entire screen, but instead it should be placed between this summary statistics title and a button that can be used to restart the quiz. So that's what we're going to work on now. And for that, as a first step, we'll add a new file for a new widget, and that of course will be our results screen widget, which will be stored in a results screen.dart file. Now this results screen widget will actually be a stateless widget, because it won't need to manage any internal state, as you will see. So this is my results screen class, which extends stateless widget, as you learned. And of course, as always, we therefore must import this Flutter package and their material.dart to unlock stateless widget. And in this results screen widget, you then should add this build method, as always. And in here, I want to output this screen, which I just showed you a couple of seconds ago. Now, if you take a look at this screen, you of course see that there are a couple of items placed on top of each other, above each other. And that always is a clear indicator that we want to use a column, because as you learned already, this is a widget built into Flutter that can be used to display a vertical list of widgets. Therefore, in this build method in the results screen, we can return the column widget and set its children argument to a list of child widgets that should be inside of this column. Now, just as in the questions screen, my column should take up all the available width though, and it should have some margin around it, and therefore we can indeed use that same pattern that we already used in this questions screen widget. Hence, I'll copy that code, and in my results screen, I'll put that before my column here, and then make sure that my column widget is actually set as a child inside of that container widget, and then I need a couple of closing parentheses thereafter. So that the code looks like this. With that, I have a column widget here, which generally takes up the entire space on this screen. And just as on the questions screen, I then also want to make sure that I center my items along the main axis. So therefore, I'll also copy this setting over to the column widget in the results screen widget. And now we can get started adding some widgets here to this list of widgets. And here the first widget is actually that text widget that tells us how many questions have been answered correctly. And for the moment, I'll just add some hard-coded dummy text here, where I'll say, you answered X out of Y questions correctly. And this can then be turned into a constant value, or actually the entire list can be turned into a constant value right now. So with that, we have this text here. Then I want to add a sized box to add some vertical spacing by giving this a height of, let's say, 30. You can, of course, always tweak this height value if you want to. And then below that, I want to have that scrollable list of questions where we have the question, the correct answer, and the chosen answer. So I'll get back to this. I'll just add a placeholder text widget for now. List of answers and questions. And below that list, which will be added here in the future, I want to have another sized box for some spacing, and then that button that can be used to restart the quiz. And for that here, I'll just use a standard text button. Of course, you could also use some other kind of button, but here a text button it is. And that text button takes the onPressed argument and a child argument. Now, the child argument should be a text widget, which sets the text that is displayed on that button. And in this case, the text should be restart quiz. And for onPressed, I'll just add a dummy empty function for now. And here I'm getting an error because of the const keyword in front of this list here, because all these widgets can be set to constant values, but the text button can't. So therefore, I'll just manually add const in front of all these other widgets, but not in front of text button. But with that, of course, this button doesn't do anything right now, but we'll soon change this. This is just the general structure of this custom results screen widget. To complete this widget for now, we also must add our constructor function here and accept and forward that named key argument. And this can also be turned into a const constructor function. Now with that, we can add some logic to show this results screen instead of that starting screen once we exhausted all our questions. So here in the quiz state class, where I currently set the active screen to start screen once we exhausted the questions, I want to set this to results screen instead. And then in the build method here, I of course also want to set my screen widget to that results screen if active screen is set to results screen. And for that, we first of all have to import this results screen Dart file in which we just worked to unlock this results screen widget in this file. And then here in this build method of this quiz widget, of this quiz state class to be precise, I want to check if my active screen variable holds a value of results-screen, which of course is the value we are setting here. And if that is the case, I'll set screen widget equal to results screen like this. And then we can add const in front of this. And if you now save this and force a reload, you should be able to start the quiz and go through all these questions. But once you answer the last question, you end up on this dummy results screen, which is not finished yet, but which generally shows the content we just added to that screen. Of course, now we must make sure that this button here works if we press it, and we need to output the actual summary information for this quiz. Now with the results screen widget added, it's now time to make sure that we pass our selected answers to this widget so that in there we can use them to show some results on the screen. And as always, if you need to receive some data in a widget, if you want to be able to pass some data into a widget, you must accept an argument here in the constructor function. And then in order to, for example, use it in the build method, you also must add an extra property to this class. So here in results screen, I'll add a new final property called chosen answers, for example, which is of type list, to be precise, a list full of string values. And now here in this constructor, we can either add a named argument or a positional argument. That is up to you. I'll go for a named argument here, and I'll therefore add a named argument called chosen answers and map this to the chosen answers property by using this dot shortcut. And since named arguments are optional by default, I add required in front of it to make sure that a value for this argument must be provided when creating this widget. With that in Quiz Dart, we now must pass our chosen answers to results screen. So we must pass our selected answers list to results screen. And of course, that's fairly easy to do because in here we already have the selected answers list. So we can simply forward this variable, or to be precise, the list stored in this variable, as a value to results screen. And we pass this list to results screen by targeting the chosen answers named argument and setting it equal to selected answers. Now we have to get rid of const, since selected answers is a list that is dynamically changed in our code. It's a variable, after all, that is set to a brand new empty list at a certain point of time, once we exhausted all questions. So it's variable, and therefore this results screen object can't be marked as constant. But with const removed, this works, and we do now receive our chosen answers inside of results screen. There, we can now use it to output some real summary statistics data here. Now, in order to output some useful information in this results screen here, we now have to kind of combine the chosen answers with the questions that we have in this separate questions.dart file. And for that, I'll add a new method here to results screen, and I'll introduce you to a new data type. But let's start with the method. I'll add a method called getSummaryData. The name, of course, as always, is up to you. And in this method here, I want to return a list of values, but now not a list of strings or a list of widgets, but instead a list of so-called maps. And that's now not a map as in Google Maps, but instead in programming, a map is a very simple data structure that maps values to keys. And in Dart, map, just like list, is actually a generic type, where you specify the type of your keys and the type of your values. So we need another pair of opening and closing angle brackets here. Therefore, we have some nested angle brackets here, which is absolutely something you can have in Dart. And this inner pair of angle brackets now belongs to map. And for my keys, I'll have a bunch of strings. So the keys in my map will simply be string identifiers. But for the values, I'll have different types of values. I will have strings and also numbers for these different keys. And therefore here, the second type I specify for this map generic type, after this comma here, which is the type of values that will be stored in this map, should be object, written like this with a capital O. Since all values in Dart are objects in the end, this is a pretty flexible type that actually allows all kinds of values. And this allows me to store different kinds of values in this map here, so that this map can simply be used as a data structure that groups different kinds of key value pairs together. Alternatively, we could create a brand new class that defines how our summary objects should look like, and then we could instantiate a bunch of summary objects here, and that would definitely also be a great approach. But I also want to introduce you to this map value and type, and that's why I'm using this approach here. So getSummaryData should return such a list of maps. Now to generate this list here, I'll start with an empty list, which I'll store in a variable, or in a final variable to be precise, called summary. And the type of this list here should be this type, since in the end I plan on returning summary here. But of course, in between creating it as an empty list and returning it, I also want to populate that list. And for that, we'll use a new Dart feature which we haven't seen before. We'll create a for loop. Now, earlier in this section, we saw if statements to run some code conditionally. And if statements are so-called control structures because they allow you to control the code execution flow. Another kind of control structure supported by Dart and many other programming languages as well are for loops. With the for keyword, you create such a loop, and a for loop simply allows you to execute a certain code snippet multiple times. To do that, you also add parentheses here, and between these parentheses, you add your for loop configuration, so to say. This configuration consists of 3 parts. The first part is a helper variable that's created for this loop. Typically, this variable is called I, but the name is up to you, and it's set to an initial value. Very often that value will be 0, but any value can be used here. Then thereafter, you add a semicolon, so not a comma, but a semicolon, which might look like a strange place, since thus far we always used semicolons at the end of lines. Now we're using it here in the middle of a line, but that is just how the for loop must be defined. And we continue with the next piece of configuration for the for loop. And that next piece of information that we have to add here is a condition that controls how long this loop should keep on running. For that, you typically use this helper variable here, I. And here I want to keep on running as long as I'm still processing chosen answers. So as long as I is smaller, and that's a new kind of comparison operator, which you haven't seen before, but just as 2 equal signs can be used to check for equality, smaller can be used to check whether this value on the left side is smaller than the value on the right side. And the value on the right side here should be my chosen answers, and there the length of this list, which also will be a number, just like I. So now with this code, the loop here, which we are about to define, will keep on running as long as I is smaller than the length of my chosen answers. So if I have 6 answers in this list, This will be true as long as I is smaller than 6, which it initially will be since we initialize it to 0. And therefore, we also need a third part here when configuring this list, where we actually control how I should change after every iteration. Because if it never changes, we create an infinite loop, since I then would always be smaller than the length of this list. Therefore, here you then control how I should change, and typically you increment I by 1 by using this ++ shortcut here. You could also set it to I + 1 like this manually, but this is simply shorter. And then you add opening and closing curly braces, and between those curly braces, you have your loop body, you could say. And that will be the code that will be repeated until this condition here is not met anymore. And in here, between these curly braces, I now want to add items to this list here. So for that, I reach out to this summary list and call the add method to add items to it. And as you learned, you can do this on final lists. Just reassigning this to a new value wouldn't work, but calling add will work. And the value I want to add here is such a map. So such a simple collection of pieces of data, of key value pairs to be precise. And in Dart, such a map is created by using opening and closing curly braces. Now, of course, we have also already used these curly braces a couple of times in other parts of the code. For example, for this loop body or to mark the body of a function. But it can also be used in places where a value is expected, like here for this add method, to create a map. Because this is the Dart syntax for creating a map value. Now, between those opening and closing curly braces, you then put your different key value pairs. And here you can add any keys of your choice as long as they are of type string. So for example, we could add a key named question_index and then set this equal to a value by adding a colon, not an equal sign. Inside of a map, you use a colon to separate the name from the value. For variables, you use an equal sign. In a map, it's a colon. And on the right side of the colon, you set the value for this key in this map. And here for question index, my value would be I. Because I'm going through all my answers, and as mentioned earlier in this section, we'll have as many answers as we have questions. So implicitly, with that loop, we're also going through all the questions, kind of. And I will change after every iteration. So therefore, it will initially be 0. And for the next iteration, it will be 1, and then 2, and so on. And therefore, I here can be used to reflect the index of the question for which we're adding some summary data to this list here. But of course, the question index is not all. Hence, you should add a comma, and then thereafter the next key value pair that should be added to this map. And the next key could be question, to add the actual question text to this summary object. And I'm creating these summary objects so that thereafter I'll have an easier time outputting all these summary statistics. So here the question text is next. And for this, we can now access the questions, so not the chosen answers, but the questions that are stored in this question start file. And to access this, we of course have to import this file. So in this results screen Dart file, we import package advanced basics data questions.dart, as we did in many other files as well. And with that here, for this question key, and I'll add some commas to get proper formatting. So for this questions key, I want to set this equal to questions, but then not to the entire questions list, but one specific question text. So for that, I access a specific question by its index, I, which is in the end based on my chosen answers. But since we populate these answers based on our questions in the questions screen in the end, I can also safely access my questions with this index here. And then, of course, I want to get the text here for a question, because this question key should store the question text. Then I also want to store the correct answer. And that's now why it was important to not shuffle the original answers list, because now I rely on the fact that the first answer in here is still the correct answer. So that here in results screen, we can set correct answer equal to questions I for the current question, for this current iteration, dot answers, and then 0. Always the first answer, because as mentioned, these answers in these dummy questions are set up such that the first answer is always the right one. And last but not least, I want to add one last piece of information to this map, so to this data collection here. And that would be the user answer, so the answer chosen by the user. And here we want to access chosen answers and then the index I. Because we're looping through all the chosen answers, so step by step we get the different chosen answers. And with that, after we went through all the chosen answers, we'll have a summary list full of such map objects, which we can now use to output our summary statistics down there. Now, with the summary data being created here, we can use that summary data to output it here instead of this dummy text widget. Instead, here I again want to display a column widget with one row per summary data, so to say, per map in this summary list, you could say. And then in every row, I want to display the question index, some indicator that shows us whether the question was answered correctly or not. And I want to display the question, the correct answer, and the user answer. We could do this all here in this results screen widget, but this widget tree here would get rather big and complex. And for that reason, since as you learned, it is considered a good practice to break your widgets apart and split them across multiple smaller building blocks, I'll do just that. And I'll add a new file here, which I'll name questions_summary.dart. And in there, I'll add my questions summary class, which extends stateless widget. And that's one S too much. So stateless widget is extended here because I won't need to manage any state in here. And as always, we should import from the Flutter package the material Dart file to unlock stateless widget. Now inside of questions summary, we of course need that build method, as we always do. And I also need to accept some data, because of course I want to use questions summary inside of results screen in place of this placeholder text widget here. And I of course want to pass my summary data, so this list of maps to questions summary then. Therefore, in questions summary, I'll add a new property, which should be a list that contains all these maps where the keys are of type string and the values are any kind of objects. And the name of this property could be data or summary data, to be a bit more specific. Now, of course, just adding the property is not enough. Instead, we need this questions summary constructor function to accept and set this summary data. And here for that, I'll accept a positional argument, though of course you could also use a named argument as we did it before for other widgets as well. And I'll add at least one named argument. I'll add this special key argument, which is forwarded to the parent widget. And this can be turned into a constant constructor. With that, we get and set our summary data here, and we can now use that here to output that column, which I mentioned before, where every row should represent one piece of summary data. So one map in this list of summary data. So for that, back in questions summary.dart, we have to set the children argument of column. And before, we always set this to a list where we then manually added all the widgets that should be displayed on top of each other. Now, I will not do that here though, because I already have a list here, this summary data list. But of course, that is a list of maps, not a list of widgets, and children wants a list of widgets. So what can we do? Well, we can transform this list from a list of map objects to a list of widgets. And we do this by using summary data here and calling the map method on that list. And by the way, the fact that this method is called map has nothing to do with this map value type. Map simply means that we map a value to a new value. So here we pass our function to this map method. And this function, as before, receives an argument automatically passed in by Dart. In this case, it will be one piece of data, you could say. This name is up to you. And in this function, we then want to return the widget to which this piece of data should be mapped. And the widget to which I want to map it here should actually be a row widget. And that's now a new widget, which we haven't used before. The row widget is, in the end, the horizontal equivalent to the column widget. Where column is used to display multiple widgets next to each other vertically, row is used to display multiple widgets next to each other horizontally. Therefore, just like column, row takes a children argument, which we set to a list of child widgets. Now, here you see that I'm currently getting an error though, and the error I do get is that my iterable thing here can't be assigned to a parameter of type list. And I get this error because map actually returns a so-called iterable object, which is almost the same as a list, but not entirely the same. And this is just some internal thing in Dart, but thankfully such an iterable object can easily be converted to a list by calling toList here at the end. So we chain the toList method after calling map. So on the result produced by map, which is this iterable object, we call toList. And now here we generate a list of rows, and in every row I then want to output various pieces of information. For example, the index of the question for which we're outputting data here. And here we can start quite simple and simply output a text widget for that. And the text that I want to display here is my question index plus 1. Because as you might recall, these indexes start at 0, list indexes start at 0, but if I want to display the number of a question to the user, it would be rather strange if I start at 0, because we humans tend to start at 1 for the first question or the first item in a list of items. That's why I want to add 1 to that index, and I can do this by accessing data and then the question index key, which is accessed like this. So you access values in your maps just as you access values in lists by using these square brackets, and then between those square brackets, the key of the value that you want to get access to. For lists, it was the index which you put between those square brackets. Here for maps, it's the key of the value instead. So between these square brackets, you then use one of the keys you defined when creating the map. So question, question index, correct answer, or user answer. And here I'm using question index. This then provides the value that's stored under that key in this map. So for question, it provides this question index, which should be a number. Here I then want to add 1 to it, and this now causes a problem here. It actually causes multiple problems, as you will see, but it causes one main problem because here Dart does not know which kind of value will be stored under that question key. Because I set this map object to be an object where the values can be of all kinds of types. So therefore Dart does not understand that here this I value is a number. I mean, it knows here that it's a number, but for the final map which it produces, it just knows that all these different keys can have all kinds of value types. It does not memorize the exact value types for the specific keys. And therefore here, this value returned by accessing the question key is also considered to be of any kind of type. Therefore, here we have to do something that's called typecasting. You can use the as keyword, which is built into Dart, to tell Dart that you know more than Dart knows and you know which kind of value this will be. You don't have to use typecasting a lot, but when working with maps that store mixed kinds of values, as we're doing it here, it's quite common that you need to use typecasting. After as, you specify the type of value you know you'll get here. So in my case here, an int. Now this should be wrapped into regular parentheses, an opening parentheses before data and a closing parentheses after int here, to tell Dart that this should be evaluated as one value, so to say. With that, Dart knows that this here will be of type int, and it then adds 1 to it, but now we have a new problem. And the new problem is that we can't pass an argument of type int to the text widget, because that actually wants a value of type string. Hence, we must convert this number here to a string, and one way of doing that is to wrap this with another pair of parentheses, but now the closing parentheses is after this +1, and then on this overall value that is derived here, which is an int, you can call toString to convert this int to a string. So a bunch of parentheses, which we here also have to use because we're working with such a map, which is not very precise type-wise, but I of course also wanted to show you this map data type in this course, because you will encounter it from time to time in your Flutter apps. And this is how you can handle it, and how you also can convert an int value to a string. And with that, we should be outputting the question number here as a first item in this row of widgets here. But of course, that's not all that should be output. Next to this question identifier here, still in that row here though, I want to output another column. And that's also something you can do, and you will do quite frequently with Flutter. You have rows inside of columns, which then might contain more columns, so that you can really structure the content on your screen exactly as you want to structure it. And if in a row, next to another item, you want to have a couple of rows, you need a column inside of a row, because a column widget allows you to display multiple items on top of each other vertically, which is the definition of having multiple rows. So here I'll add another column so that inside of this column, I can output the question, the chosen answer, and the correct answer. So for this here, in this list, which again should be a list of widgets, we can start with the question, output with help of the text widget. And for this, we can access data question, and this here actually should be question index, of course, therefore. So here I want to access the question. And again, Dart does not know which kind of value we'll get here, but it does know that it wants a string, and this potentially isn't a string. It could be any kind of value, and therefore we again have to do some typecasting here to tell Dart that we know that this here will be a string. And with that, we're outputting that question. Now below this text here, which represents the question, I want to have a little sized box for some spacing, some vertical spacing by setting some height here. And then more text widgets, one for the selected answer and one for the correct answer. Now for the selected answer, we can and should access our map and then there the user answer, because that is the answer chosen by the user. So user answer it is here. And again, we need to tell Dart that this will be a string. And then below that, we output the correct answer by accessing correct answer on this map here. And with that, we should be outputting a list of summary data. So therefore now we can go back to the results screen and use this questions summary widget there. So for that, as always, it must be imported there from our own package, the questions summary Dart file. And with the import added, here instead of that placeholder, we can now output questions summary, and we have to pass our summary data to questions summary, and that simply means that we must execute this function, which generates and returns that summary data. So therefore, down here, we should call getSummaryData and execute it as a function. Here, we're not passing the function name as a value, because questions summary does not want a function as a value here, but instead a list of maps. And that's exactly what getSummaryData produces, but therefore we also have to call it here. And with that, if you save this all and reload everything, you should be able to restart the quiz and pick any answers here, and you end up on this results screen where we actually got no list here. What's the problem here? Well, the problem is this line of code in our quiz state class in the quiz.dart file. Here, we are resetting the selected answers back to an empty list. And therefore, of course, since we call setState, when the build method executes the next time, we're passing this empty list, which we set here, as a value to the results screen. So there basically are no selected answers there. Now, we did this before to avoid an error when we restarted the quiz. And we will still have to do that when we restart the quiz, but now we aren't restarting the quiz here. We're showing the results screen instead. So therefore here, this code should be removed, and we'll bring it back later once we take care about adding a restart quiz functionality. For now, we should get rid of it, and therefore now if we save this and restart, we should be able to answer here. And now we have our list here. Of course, pretty ugly, no formatting. Also, in my case here, with some strange error, which is simply a little feature provided by Flutter when running this app in development to show you that some widgets are cut off and are going outside of your screen boundaries. But we'll take care of all of that soon. What you can still see, besides this being broken, is that we have our question numbers here, and that in the end we seem to have some rows here. For example, this here is a row, this here is another row, and in every row we first have the index here, and then next to it we have more columns here, for example, where we then have the question and the chosen answer and the correct answer. So our layout generally works. We have an overall column with multiple rows, and in every row we have two columns, one column with the index, and then another column with more rows, with the question and the chosen answer and the correct answer. But of course, as mentioned, it's ugly and it's broken. So that's what we'll fix next, therefore.